Today we're going to look at the 2025 paper 2 for AdMaths. So I just want to say welcome to my channel. My mission here is to inspire the future generation of engineers, mathematicians and physicists, and even if you just want to pass, you could still gain something. But I believe in going real in depth with the solutions in such a way that you could understand and learn something new. Right, so Achilles, let me go. I'm gonna share my screen there. Right, so here was one of my outside children, not my original student, one of my outside children. Right, so Achilles, tell them all the hello one thing.
Hello everyone, I'm going to see what mark I get from my AdMaths paper there.
Right,
I do good.
Right, so let me check this thing, right? Okay, so as you guys could see, this is our perfect copy. Big up myself at MathVybes, right? So let me read the first question. Section 1, algebra, sequences and series. Solve the equation 3 to the power 2x plus 1 is equal to 21, giving your answer in exact form. Now the first thing I notice here is that what I'm trying to find, the unknown, is our power. And you seeing that too? X is our power over here. Tell me if you're seeing that.
Yes, sir.
So anytime what you're trying to find for is our power, you need to apply logs. The reason for that is because when you apply logs on both sides, you could use the power rule. Right? So I'm going to apply log base 10 on both sides. So I'm going to say log 3 to the power 2x plus 1, and that's going to be equal to log 21. You understand everything I do there, right? Nothing frighten you.
Yes, sir. Nothing flying over there.
Right.
Apply logs. That will be working. First time.
And since everything is to the same log base, I could take the power 2x plus 1 and bring it to the side. Now because 2x plus 1 is a binomial expression, I need to put that in brackets when I move it to the side. So I'm going to put inside here 2x plus 1 in brackets by log 3 is equal to log 21. Right. Now I'm trying to find for x. Should log 3 be over here?
Nah, sir. Let me move that out of the way.
Right, so it's 2x plus 1 is being multiplied by log 3, so I could divide by log 3 on both sides. So the log 3 and the log 3 would cancel off, so we remain with 2x plus 1, and that's equal to log 21 over log 3. Now, I want you to take something into consideration. They're saying to put the answer in exact form. You see that?
Yes, sir.
So you have to leave your answer in terms of logs. So log 21 over log 3. We're going to move across that one. If you move across that one going to become negative 1, right?
Log 10 at 10. Oh, yes.
Oh, I see what you're doing. So, if we move across the 1, it'll become minus 1, right? Okay.
Sir.
Yeah. Tell me.
Alright.
So
what I do in the exam, when I get that, I just divide everything by 2 to find x. And then, when I have a Casio, so I just input that whole equation into my calculator and I get my answer. Easy format to me.
Right, but you have to write your answer in exact format. Exact form. Yeah, you can't write your answer as a decimal.
Okay.
Right,
so we had to have
yeah, you have to write
equation in third form.
Yeah, you have to write everything in the exact form, right? So, as you were saying, 1 is the same thing as log base 10, right?
Yes, sir.
Okay. So I have this log expression. Now, let me ask that question, right? It makes sense to convert that log. It makes sense to convert minus 1 to log base 10?
Well, it depends on what you're going to do. If you're going to use the quotient law again, you just turn into log 21 over log 3 over all of that entire fraction over log 10 divided by log 10.
But I want to bring something to your attention, right? If we're looking at the product, if we're looking at the quotient rule, doesn't the quotient rule say log base AB, right, minus log AC is equal to log AB over C?
Yes, sir.
Both of these terms, but look at something. Both of these terms are log terms. Are you seeing any quotients there? if I want you to recognize something,
No.
aren't both of these log terms like individual log terms?
Yes, sir.
Yeah, but what we have over here though?
We have a fraction or
Ah,
quotient here.
so tell me, you think we could apply that
Alright,
rule?
so
You think we could apply that rule? Is it in this exact form?
yes, sir.
Nah.
No?
To use this rule, you must have log base AB. Over here we have log base 1021 over log base 103. We don't have a single log, and we cannot combine that
Okay.
into a single log. You understand? If it was something like log 21 minus log 3, I could have combined that into a single log, like log 21 over log 3, right? I mean, what's it?
Yes, sir.
I could have combined that to log 21 over 3, and that's a single log, and then it would be in this form. So it, truth be told, it really does not make sense to say minus log base 10. It's not like we can combine it. We can't combine it because it's not in the form of that. And so what I'm going to do now, so I have 2x is equal to this entire expression. Am I trying to find for 2x or am I trying to find for x?
X.
Right, so I'm going to do what on both sides?
Divide by 2.
Right, so I'm going to say log 21 all over log 3 minus 1 all over 2. Right? So x is equal to this over here. Log 21. And if I want, right, and I could split up this fraction into, and I could split up that fraction into each term.
Log 21 minus log 3 minus 1.
So,
Oh, yes.
yeah, watch. And I could write this, if I wanted, I could write this as log 21 over log 3
All
divided
over
by 2, right?
Yes, sir.
Minus 1 over 2. And end dividing by 2 is the same thing as multiplying by a half.
Yes.
Yeah, so watch this, right? Watch this. Look what's gonna happen. We're gonna end up with x is equal to log 21 all over 2 log 3. Let me know if I lose you there. Because, check this, right?
No, you didn't. Yes, I understand what happened.
Bam.
You multiply by a half, so the third in the denominator and it'll go by the 2 log 3.
Exactly. And so we could write this as x. You see how we have a 2 to the side? We could bring it up using the power rule. So you're going to end up with log 21 over log 3 squared minus a half. And I think that's as simple as it gets. This is as simple as it gets. Agree?
Yes, sir.
Right.
Alright.
Right, so that's the answer there. That's like an exact form. You can't simplify that any further. If you do simplify that, you're gonna end up with you're gonna plug it into your calculator and you're gonna end up with decimals. They wanted this in an exact form, so this is the answer. And tell me something. How would I check if my answer is correct?
I'm not sure how you do that. Or you could you input it in your calculator.
Let me show you, right? Let me show you. So in any equation in maths, the value for the unknown is supposed to satisfy the equation. So look at what we're gonna do, right? I want you to plug this into your calculator and let me know what you're getting.
Alright.
So again, you understand why I couldn't combine this and this, right? Because log 21 over log 3 wasn't a single log term. Understand?
Yeah, it wasn't one log term.
It wasn't
2
one.
log terms, it was already 2.
Yeah. So I want you to plug that into your calculator and let me know what you're getting for x to 2 decimal places.
Right, sir. See.
You're supposed to get 0.8.
89.
Right. And here what I'm saying, in maths, anytime you're trying to find for unknown, you are trying to see if it satisfies the equation. So you're going to take 0.89 and you're going to plug it in here. And you're supposed to get something extremely close to 21 using the rounded off value. So you go in the calculator, you're going to put 3 to the power 2 by 0.89 plus 1. So do that and let me know if you get something very close to 21, in which case you would be correct. Ah boy.
Yes, 20.20.
Right, and the reason we didn't get exactly 21 is because we didn't use the exact answer. If I plugged that into my Casio, which I could, I would get exact 21. So, you're good, right? First question down.
Hmm.
Now, here what? I don't think they're that critical. I don't think you have to simplify it this much, right? I think probably if you had this line where x is equal to this, you're supposed to get full marks because this is a lot, right? But you're okay with it. I didn't lose you anyway. Everything makes sense.
Yes, sir.
All right. Determine the values of x and y which satisfy the equations. All right. I'm seeing two equations. Anytime you see two equations and two unknowns, we have to do
Simultaneous equations.
simultaneous equations, right? So I'm gonna call this equation 1, right? And I'm gonna call this equation 2. But let me ask you a question. In equation 2, right? And I can simplify that.
Yes.
So
you get a quadratic.
I would do that, right? I would say, so since we have an x on the outside, you would need to use the distributive properties and multiply every term on the inside by x. So that's going to be y plus 4 is equal to 5x minus 2x squared. Right? And if I want, I could take the 4 and move it across. I don't know if you see what I'm doing.
Yes, sir. Make a quadratic there, and then you could, in one, we can make whatever we want the subject of the formula. Well, x, make x, not x, y. Make y the subject, and then you can.
What do? What did I just do? Check that.
You made y the subject, right? Yes.
I hit it in one shot. Now, guys, it have several ways you could work a simultaneous equation question. In a simultaneous equation question, you want to express one unknown in terms of the other and then plug it into the other equation. So I could have make y the subject of the formula here, and that would be 2 minus 3x, and anywhere I see y here, I could have said 2 minus 3x. Yeah or no?
Yes, sir.
Right? But over here, I just choose the hard way. I say let me move across 3 plus 4, make it minus 4. I expand that, and that's what y is equal to. So in other words, anywhere where I see y in equation 1, which I did not use as yet, I could replace y with what?
5x minus 2x squared minus 4.
Right. 5x minus 2x squared minus 4. Right? And I just now replaced y. So this is y here. So this whole thing is y. Right? Plus 3x is equal to 2. Now, and you clearly see that it's starting to look like a quadratic.
Yes, sir.
So let me put it in that form one time. So I'm going to say minus 2x squared. Right? And notice I have a 5x and a 3x. And I can slap that together and get 8x.
Yes, sir.
That is you. I can't expose you on YouTube. I can't expose you on YouTube. Yeah, I mean, I feel like it's Nicholas, right? On the right hand side, we want to move it across because we want to get it in the form of a quadratic. And a quadratic is being the form ax squared plus bx plus c is equal to 0.
Equal to 0.
So if I move that across, it's going to be minus 2. And so I'm going to have minus 2x squared plus 8x minus 4 minus 2 is minus 6. Now, to solve that quadratic, I could simplify it a lot. So, first thing I could do, I could divide by 2 throughout, right? And then we could do something else as well. So we're gonna, if we divide by 2 throughout, we're gonna end up with minus x squared plus 4x minus 3 is equal to 0. And additionally, it's easier to factorize quadratics whose coefficient for x squared is positive. So I could always multiply by minus 1 on both sides. Right?
Minus 4x plus 3.
Okay, right? And if I want to factorize this, so this is how I do it. This is a simple trinomial, meaning that the coefficient of x squared is 1, so it's really simple to factorize. So what would I have to multiply to get x squared?
What? That'll be x by x.
That'll be x by x, right? And then I'm looking at the last term. How are you doing this is you're looking at the last term, right? And you're trying to figure out a way to multiply to get the last term, but also add to get the middle term. So, how you can multiply to get 3 and add to get negative 4?
All minus 1 by minus 3.
Right. And that is your answer, eh? One time, bam. So, I could say x minus 1 is equal to 0. And I could say x
0.
minus 3 is equal to 0.
1. And x is equal to 3.
Now if you find I'm moving slow, if you find
and
I'm
the
moving...
question taking is,
Oh, see, so you get x is equal to 1 and you get x is equal to 3?
yeah, in the test. But I didn't do that. I seen this, I kind of looking like I make myself do real plenty work. I pull up that whole thing with working.
Damn. So this was easier.
Yes, much easier.
Okay, well, good, right? And so now that I have the two values for x, I can now plug that into y. And again, if you find I'm moving slow, this video is not just to help you and for you to see what mark you get, it's to help a bunch of other people. That's my mission, right? And
No problem there, sir.
And so, hence we have a third equation that is directly telling us what y is equal to.
Yep. So
Yeah.
you can just use that one time.
Right, so over here, anywhere I see an x, I replace it with 1. So that's going to be y is equal to 5 by 1 minus 2 by 1 squared minus 4. Plugging that into the calculator, tell me what you getting. Minus 1 is supposed to get.
5.
Let me see if let me see these sleepless nights affecting me today. I want to try to do as much mental maths as possible. Alright? So the first point is 1 comma minus 1. Yes or no?
Yes, sir.
But you don't have to state the ordered pairs, eh? You don't have to say this. They just ask you for the values of x and y which satisfy the equation. So you don't have to put this. This is optional.
You look real mad if you do that, sir. I find you do all that work and I just have it all day. It just makes people like easier if you do that, I find.
For sure, for sure. And now we're going to replace x for 3. So that'll be 5 by 3 minus 2 by 3 squared minus 4. Okay? And so we're going to end up with 15 minus 7. I wonder if minus 7 is the correct answer.
Yeah, trying right now, sir. Minus 2 by 3 squared minus 4. Minus 7.
Way on fire tonight, you know, on fire tonight. I like a sukun, yeah. Right? So the point here will be 3 comma minus 7. So these are your values for x and y. So your value for x is 1, value for y minus 1. Your value for x is 3, your value for y is minus 7. So we good?
Yes, sir.
Easy 6 marks, eh? Easy 6 marks. The only question I find was tricky. Okay, so you get this, right? You get it.
Yes.
Alright. The only question I find was a little hard was the trigonometry proof. That's all.
Yes.
That's all. Right, determine the solution set for the inequality. Alright, before we do anything, right? Before we do anything, this is a rational inequality. Right? Rational inequality because it's a fraction. Anything that you could represent as a fraction is called rational. Notice you have x minus 1 in the denominator. And you can see that?
Yes, sir.
So what value for x would make this function go crazy?
Oh, positive 1.
Let me say it in the proper terms, right? For what value of x would make the equation invalid or undefined? 1, right?
Yeah.
So guys, you cannot divide by 0. Pause, plug that into your calculator. Try to divide 1 by 0. You'll see that your calculator tells you you're crazy. So when I'm including my range, so when you're looking at the notation, you see in less than or equal to. So when you're writing a solution set, you might be tempted to include 1 in your solution, but automatically you can't include 1 because 1 minus 1 will be 0 and you'd make the denominator invalid. So we're writing that from the start. So x cannot be equal to 1. Yes or no?
Yes.
Right. And we have 3x plus 2 all over x minus 1. With these questions, you would divide, we're saying divide, you would multiply throughout by the denominator squared. So you can get both solutions. So again, I'm not really skipping much working because I want this to benefit as much people as possible. I just try to move a little faster. On the right hand side, 0 by anything is what?
0.
And then x minus 1 squared is the same thing as x minus 1 by x minus 1. And so this x minus 1 will cancel off with 1 on top.
Yes, sir.
Right, so on the left hand side, I'm going to end up with 3x plus 2 by x minus 1. And that's going to be less than or equal to 0. Now for this particular question, it's looking kind of scrappy. I love these cases. And you love these cases because they're easy to factorize. It's already factorized. So we could find the critical values easily. The critical values are where x is equal to 0, basically the intercepts. Right? So I'm going to say 3x plus 2, put that equal to 0. So 3x would be equal to minus 2.
X is equal to 1. But we can't say x is equal to 1. Now be invalid. So it's just x is equal to minus 2 over 3, correct?
Nah. Hold your horses. You go see what happening, right? So these are my two critical values. So now we need to study how the graph behaving. So if you were to expand out this, wouldn't you get 3x by x is 3x squared? Yeah, we get.
Yes, sir.
And so if we're looking at the coefficient of x squared, a is more than 0. So if a is more than 0, you're positive. So if you're positive, you're happy. And so that'll be a minimum, right?
Minimum.
Definitely a minimum. So here what? Let me do a quick sketch. And so I'm gonna draw my x. I'm gonna put my x values first. And so the graph gonna cut at 1 for 1 there, and I'm gonna cut at minus 2/3. Now the next thing I'm gonna add is my y-axis. So where do you think I should place that? Think I should place it here, in the middle?
In the middle of the curve.
Right, and the reason for that is because, guys, imagine a number line. So the y-axis passes through x is equal to 0, and if you have a number line, and you would have positive values to this side and negative values to that side. Make sense?
Yes, sir.
So you kind of need to have the y-axis in the middle. And so we wanted to see where the function is less than or equal to 0. Less than or equal to 0. That's very interesting. Alright? So let me do that. So less than or equal to 0. If we're talking about less than or equal to 0, we're talking about it could be 0 or it could be negative, right? Less than 0. And that's what less than 0 means?
Yes, sir.
This means it could be 0 or negative. Because if we go past 0, on the left side is negatives. So we're trying to see where we get our negative read off. To do this, you're gonna do the vertical line test and see where you get see where it cuts the x. You see where it cuts the graph, and then take a horizontal read off. So let me try on the inside now. It cuts in the graph here. Oh, does that give me a negative value?
Yes, sir.
Right, because this is the negative values for the y-axis, right? What's about over here?
That'll be positive.
Positive.
No negative as well. Hear me? Thank you.
What? Negative again. Let me try taking a value on the outside. What if I take a value that's less than minus 2/3? What happened in there?
Is a positive y.
Right, because all of that is the positive values, right? Let me try over here now. Positive or negative?
Positive x, positive y, yeah.
Right, so that can be it. So my solution lies inside between the values minus 2/3 and 1. Let me know if that makes sense. Right, so I need to write my solution in set builder notation. So since my value is in between two values, look at what I'm gonna say. So guys, anytime your answer is in between two values, you write it in this particular form. Alright, so let me write the solution. So our solution is gonna be x is such that A, when you're writing it in set builder notation, A is the smaller value and B is the bigger value. So the smaller value here is minus 2/3, and I'm going to say less than or equal to x and less than or equal to 1. But there's an error here, and that's not correct. Can you tell them why that's not correct?
X can be equal to, well, it can be equal to 1. It could be less than 1.
Right, so this is what you needed to put in your answer. You couldn't have put less than or equal to 1, because if you include 1 in your solution set, for that interval, your function is going to be invalid and undefined. So we good?
Yes, sir.
Did you do that? I
Like I
guessing.
said, I do that, sir.
I guessing not. I
Well,
guessing.
I get the minus 2/3, but I didn't put a little x is less than 1. I ain't mess up there.
Yeah. And here what? This, you see how this solution set is less than 1?
Yes, sir.
That directly relates to this question, right? So let me look at this question. State how the
Yeah, I do
solution
not
of.
know what to do for this, sir. I find the correct thing. I get the top part correct. I watch it, so it's like, why doing it?
Okay, so I think you've seen it now. Because if you look over here, look at this function. That function would be undefined for any particular value for x.
No.
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 You
My
could
gosh.
you could plug in any value for x into that. And so didn't we solve a case like that already over here?
Yep.
Yeah, but you see the thing is, right? This over here is derived from this, so it comes from that. It's not like this is a standalone equation. So if I were to have this equation by itself, the solution will vary from this. And so we know what the solution for this is. We know what the solution for that is. I don't even know how to sketch it. And the solution for this would be
X is such that minus 2. X is more than minus 2, so but less than or equal to 1.
Right, because you don't have a fraction. You don't have a fraction for this. Yeah, that was it. And you could probably label this equation 1, and you could probably label this equation 2, and you could say this is the solution for 1, and you could write that this is the solution for 2. So minus 2/3 less than or equal to x less than 1.
You'd have to do all that, sir. You'd just have to put equation 1 and move on with it.
Okay, what you had to say, so you're supposed to say solution 1 contains 1, whereas solution 1 does not include 1. Right? So solution 1 includes 1 in the solution,
Oh, boy.
you don't have to pull out this. I just put in this so people could learn. The only thing you're supposed to say here, so like literally the
Oh
only
no, I
thing.
went word boy because I see how I lost from I wasn't even watching my phone for a good while there. I was writing down the solution.
Right, so you understand that. So the only thing you had to write in this question was equation 1 includes 1, equation 2 does not include 1, because you would make it invalid. That's all you had to say, right? You didn't need to include this. We being fancy over here, if I'm being honest. And like these are the things that would get you in the merit list. Alright, let's continue. The relationship between the two variables x and y is 10 to the power 2x by 10 to the power y is equal to 3. Express the relationship in the form y is equal to log b plus ax, where ab is an element of the real numbers. That being said, we have an exponential form here. This is exponential form. And we go in from exponential form to
logs one time.
To linear form, right? You was there when we was doing this like in the 17-hour marathon. And you was there? I remember talking to you.
So I don't think so.
Damn, we do this. We do all of this.
Sorry, I just remember.
Right,
I know you do everything because that red helped more, but I remember when that 2 o'clock reached and I finished, that probability was right. Time for me to sleep.
And probability was one of the easiest things this year. I know you're not tree diagram on income, right?
Yeah.
So let me go, right? Let me go. So I'm going to apply log based 10 on both sides, which is just understood to be log, right? So I have 10 to the power 2x by 10 to the power y is equal to 3. So I'm going to apply log. So that's going to be log 10 to the power 2x by 10, you see already solving it in my head. I autocorrect into the solution. Okay, and if you notice, don't we have a product of terms on the inside?
Yeah.
So
we put in that to log 10 to the power 2x plus log 10 to the power y.
Correct. And which one of the indices rules we're using?
I can't even remember. I don't even remember the particular law.
We're using the product rule, but in reverse. Anytime you have the same log base and you're adding them, you could write it as a product of the arguments. By the way, we call these arguments, this is the base. Yeah. Right. So you see this 2x? I can take that 2x and move it to the side using the power rule, right?
Yes.
You see how we have log base 10 over there? What are going to turn to?
Could be just 1.
Yeah, watch. So this whole thing going to turn to 1 because log base 10 is 1. This whole thing going to turn to 1 because log base 10 is 1 as well. So we're going to end up with 2x.
3. Well, log 3.
Right. And so we're going to make it in this exact form, right? So we have this, and so we're going to move across that 2x on the other side. Yes or no? We're going to move across y on the other side.
Yeah.
Yeah, we're going to move across.
But then you get minus 2x, huh?
Yeah.
And that's where because I reached this thing.
Well, let me ask that question, and I could write this as plus minus 2x. So is there really a problem? Because that's correct, the correct answer is y is equal to log 3 minus 2x. And if you wanted, you could have compared this and this, right? It's in direct form. So watch this. So b is 3 and a is minus 2. You see that?
Yes, sir.
Right.
Well, good thing you just leave it so, I say, I don't know what they want me to do from there again. If it's so, leave it so. I take my marks.
Okay, yeah. But something that's peculiar here, right? Notice they're saying that a and b are elements of real numbers. Yeah. And negative 2, is that a real number? No, negative 2 is not a real number. Real numbers is like 1, 2, 3 numbers you'd use in day-to-day life. I think that's like a oversight on their part, because we did everything correct. There's nothing wrong over here, right? We did exactly what they wanted, and so this is the answer. You okay?
Yes, sir.
All right.
Sorry, my mic was muted.
That is okay. Right. Hence, state the value of the y-intercept of a graph of y versus x. So check this, right? If I were to rewrite this in the form y is equal to mx plus c, I would say y is equal to minus 2x plus log 3. Can you see it?
Yes, sir.
And
the
so,
gradient will be negative.
Right, the gradient will be negative 2 and the y-intercept would be?
Log 3.
Right. Right. Part B now. So how much marks I get here?
I get the full 4.
Mm-hmm.
I didn't bother changing it around though, so I left it at log 3 minus 2x.
Ah, well, they go and get 3 marks because they wanted it explicit. 3 marks. They wanted it explicitly in this form, and they stated it that they wanted it in that form. So if you did not express it in that exact form, you lose marks.
Alright, wait.
Right? You gotta give the people what they want. Right? Determine whether.
I like this question.
Determine whether the series 2 plus 6 plus 18 plus 54 plus 162 is arithmetic or geometric. So let me start off, right? If a series is arithmetic, all of the consecutive terms are linked together by a common what?
Common difference. Plus or minus.
Right. Arithmetic would have a common difference. And we would use D to denote that. And the formula for D is the next term plus the previous term. For geometric is equal, that would have a common ratio. And what's the formula for the common ratio? No, what I'm saying, boy? Oh God. You catch me lacking. Right? Tn plus 1 minus Tn, right? And this could be Tn plus 1 all over Tn. Agree?
Yes, sir. I don't get caught lacking. I don't forget that, but I just not ready for it.
Wait, you don't want to forget too much, eh? So,
yeah, 3.6.
So let us see if it is a geometric series. If it's a geometric series, if you find multiple common differences, it should be the same, right?
Yeah.
So let me see. So you could say the second term minus the first term. So 6 minus 2, that would be what?
So you mean arithmetic series, you're testing if it's arithmetic first?
Yeah, testing if it's arithmetic.
Yeah, that would be 4. The difference would be 4.
Right?
Yeah.
And
it is an arithmetic.
If it attests both cases, right? Both cases.
Yeah.
And so this could be 18 minus
I'll
6.
try the next 2 terms.
Okay, watch that.
Nah.
Does not. The reason why we just call it common is because it's common throughout all terms, you know. Does not have a common difference. Let's try it over here now. So for a geometric, it should have a common ratio. So let's try that. And so we're gonna say R. So we could say 6 over 2. What is 6 over 2?
3.
Let me try some other terms.
18 over 6.
What's that?
3 again. And we'll get the same thing.
Right? So since the sequence has a common ratio, it is geometric in nature. It is. Right, you get a mark, right?
Yes, sir.
Okay, cool. In a geometric progression, the third term is 25 and the sum of the first and second terms is 500. Find the common ratio where r is more than 0. Okay, so we're dealing with a geometric progression. The third term is 25, so T3 is equal to 25. And the sum of the first and second, so that means
T1 plus T2.
Marks a question, right? What we have
Yes,
there.
sir.
So and we could come up with
3 equations.
right, and we could come up with an expression for both of them.
Yes.
Okay, so
You substitute the general formula for GP.
right, so the general formula for GP says that T of n is equal to AR to the power
n minus 1.
right. So for the third term, I can write that as, do I know my first term?
No.
No. Do I know my common ratio?
Yeah, no.
No, I don't know what that is either. So that will be 3 minus 1, which is 2. And so AR squared will be equal to 25, right?
Yeah. So you know the funny thing?
What's that?
During the exam I find a way to find A before I solve for R squared.
Oh, yeah, you're bad. You're real bad. Right? And so the first term is just A, right? And the second term, that will be AR. Are you doing anything that's crazy so far, or like you're good?
I'm good, sir.
You understand that the second term will be AR to the power 2 minus 1, which is just AR. Alright.
Mm-hmm.
So now you had so essentially anytime you see two unknowns is simultaneous equations, right? So we have our unknown, we have two unknowns there and two unknowns there. We need to come up with a third equation. So help me find a third equation. Which one you want to make the third equation?
I'd just make R the formula, the subject of the formula in 1. And r is equal to the square root of 25 over 8.
You like to make your life hard, and you like to make your life
Yeah.
hard. Why would make
And using my new stay up for 17 hours helping me do hard math, helping 100 people do hard maths
yeah?
the day before the exam.
So what I would do is I would factor out a, and I would say 1 minus r is equal to 500, and so a will be equal to 500 over 1 minus r.
Okay. Yes, yeah.
Right? So I would say that is equation 3, and I would plug that into equation 1, and so that would be a by 500 all over.
It'll be r by 500 over 1 minus r. If it's a is equal to 500 over 1 minus r.
I'm tweaking. My bad, gang, my bad. Right? So a is that, and r squared is equal to 25. Tell me what next?
Alright, well, it's basically making r the subject of that formula.
Right, so we have 1 minus r in the denominator. We hate working with fractions, so what will we multiply by on both sides?
500 over 1 minus r squared.
Nah, I would multiply both sides by 1 minus r. Think about it.
Just 1 minus r.
If I multiply
yeah,
both sides,
okay.
yeah or nah?
Yes, and I have it on that side.
Right. And so if I do that, on the left hand side, that's going to turn to 500 r squared, and that's going to be equal to 25 by 1 minus r. You good?
Yes, sir.
Okay, we're good. Okay. And we good is, do we have any greatest common factors here? Like, how many things I could possibly divide through to simplify the expression?
5.
I see in something bigger than 5, you know.
25, yeah.
And if I do that, I go end up with, that will be
1
20.
minus r.
That will be 20 r squared is equal to
Is
1.
equal to 1 minus r.
So easy we make that. Like,
Yes, sir.
right? So then I'm going to move across everything because we recognize that it's starting to look like a quadratic. And so that's going to be 20 r squared. I'm going to move across all of these terms, so the signs are just going to be negated. So that minus r going to into plus r, that positive one going to into minus 1, and that's going to be equal to 0. So what did you do from here?
Simple solve the quadratic. Sum
Alright.
product, whatever else you want to do. Have you tried the thing yet? You can do the same
Let me see.
shortcut yet.
You're supposed to be able to do it, right? So just by looking at this, I think the answers will be a quarter or a fifth, just by looking at that. So like, to get 20 r squared, and I can say 5r, and I can say by 4r,
Yes.
and I can say 1 by 1, and I want to get positive 1 in the middle, positive 1r. So I get positive 1. To get positive 1, I would need to put the plus sign over here and the negative sign over here, and that is equal to 0. Simple, right? And we could verify if it's correct, right? Because let me check that real fast.
Let's expand it out, yeah.
So 5r by 4r is 20r squared. 5r by 1 is plus 5r. Minus 1 by 4r is minus 4r. Minus 1, yeah. Is that correct?
Yes. Oof.
Real badness. See how fast I do that? You could do that. To all the students who are watching, this method, once you practice enough, you'll become like insane at this method. And you can get it immediately. Right? So remember how I told you the answer was either a 1/5 and a minus a quarter? Yeah, you see? I look at that and figure that out. You could do that. So 5r minus 1 is equal to 0. 4r plus 1 is equal to 0. And so I would move across the negative 1. So that is 1. And divide both sides by 5. So r is equal to 1 over 5. And over here, r would be equal to negative 1. And then I would divide by 4. Which one is the only?
R is equal to 1/5. It can be minus 1 over 4.
Guys, pay attention to this. They said r has to be more than 0. So the only valid solution is 1/5. Right. So, yes or no? Are you okay with this?
I understand. I see the way. I really didn't have to do what I do in that exam. Thursday? Yeah, Thursday.
And
Yesterday.
And how would you verify if your answer is correct?
substitute it into T3. Well, T3 is equal to 25.
So you would have to find for A first, right? So let me go the extra mile. So this is the answer, guys. This is what we'll get the 4 marks. But we have trust issues here, right? Mr. Achilles has been heartbroken a couple times. A little juice wall and thing. I'm joking. Right? So if we want to see if our answer is correct, we could find for A real fast. So put 500 over 1 minus 1/5 and let me know again. You should get, let me do the maths in my head fast. You should get 300. No, you should get 2. Wait.
I just dropped my calculator.
Oh, okay. So that'll be 4 over 5. And that'll be 100. 625. So we get 625, I think.
Yes.
Damn, I've had enough. Right, so we get 625. And if the first term is 625, let me try something now.
Let's find the second term. 1/5 625.
But we're gonna run into a problem there. We're going to run into a
What's
problem.
it?
You get 1/5 as the answer.
For R? Well, no, I see it again. I'm wrong. I remember in the exam, I think I get positive a quarter. I just say I do something wrong for this one.
Let me check something. I'm scoping out the scene. 500 hours.
With carry that? I carry 1/5.
Let me try to find because it can't be 1/5. The reason why I'm saying that is because if I say 625, if the first term is 625, right?
And the second term is 1/5 plus 625. It's not adding up to 500.
Nah, they're not adding up to 500. So something smelling suspicious. Let me see if we do anything wrong. So the third term is AR squared, and that's equal to 25. Verify that that's correct. That makes sense, right?
Yes.
Right, and then we have A plus AR is equal to 500. The first term is A, obviously, and the second term is A by R, and that's equal to 500. So then we're saying, I pull out the A, so A by 1. Oh my god. Yo, that's crazy. Watch this. You seeing that? Damn, that's crazy. That's real crazy. And so, let me correct you.
That has to be 1 plus R.
Oh my god. And so you're really supposed to end up with 20R squared is equal to 1 plus R. And so that'll be equal to
R. Yeah, 20R squared minus R.
Yeah.
Plus 1. Wait, no, minus 1.
Minus R minus 1. Both of them going to be negative.
Yeah.
And so if that is the case, right, you're going to end up with, so we want to get a negative. So, you see, by doing this, I kind of showing earlier the importance of checking back your answer. Seeing that is a very important skill, right? Because in maths, everything you do is supposed to add back and you're supposed to get your original answer. Yes or no?
Yes, sir. Boom. Maybe I didn't get the whole thing wrong.
Right, so let me check it back real quick. So 5R plus 1 is equal to 0. Then R would be equal to negative 1/5. So that's a wrong solution. And then R would be equal to a quarter. So that's it. That's what you get, right? A quarter.
Yeah.
Okay.
Hey, I got them. I keep the 4 marks. I didn't lost them.
Big up yourself. And if we wanted to check if that's correct, we could find the first term real quick. So that will be 1 minus a quarter. And the first term then will be what?
First term? Yeah. Casio for it again, man.
But that's still real weird though. That's still...
Yeah, I didn't check this so many exams because I was real put after this, but like...
Again 400. Things making sense. Yeah, working out. Yeah.
You get 400, sir?
Yeah, because remember we didn't make the mistake with the negative, so this really supposed to be plus. That really supposed to be plus. 1 plus a quarter.
Yeah.
Yeah. And you're supposed to get 400, and that makes sense, right? That makes sense. And then the next answer would have been 400 by
1
a quarter. And you'd get 100, and 100 plus 400 is?
500.
Right. So Achilles, can we stress the importance of checking over?
Never.
Never, I could never stress that. Like, it's very important, guys. Very important. And maybe I'm making mistakes on purpose to show all you that even if you think you're confident and you're real good in maths, it's very easy to make a mistake. And going forward, you need to check. You need to check through 100%. If you have time, please check your answer. So, this was an example. I'm not going to make any more mistakes. I think I'll get the importance of checking over mine now. So, let's do part D now. So, a kitchen garden has an area A is equal to 10 minus 3 root 5 meters squared. The length of the garden is 5 minus 2 root 5. Determine the value of A if the width of the garden in meters is in the form A plus root 5, where A is a real number. So let me hear, what did you do?
I instantly find out it's a rectangle the minute they say length and width, and I see a right area of a rectangle length by breadth. So I say A is equal to 10 minus 3 root 5 on a form equation, and then I substitute the length they gave us, and then I substitute A plus root 5, and I just find, well, I was smart, and I just divide throughout by A plus root 5, because width will be area divided by length, and then I end up with A plus root 5.
Okay, nice.
Or I didn't divide throughout by A plus root 5, whatever.
So
I find A plus root 5.
So you understand that we have area, they gave us area, and we know for sure it's a rectangle because we can't assume it's a square, right? If it was a square, that would be too easy. So we have A is equal to 10 minus 3 root 5, and that is meters squared. And so we understand that it's a rectangle, and to find the area of a rectangle, how would you do that? What's the area of a rectangle? The length by the width, right?
Length by breadth.
Length by width. So I'm going to plug in everything I know. 10 minus 3 root 5. Right? What is the length?
5 minus 2 root 5.
And what form is the width in? What form is the width in?
A plus root 5 by A is a real number.
Right. So I want you to understand what I'm doing here, right? I'm making an equation. They're telling me that the width is in the form A plus root 5. So that's what the width is. We just don't know what A is. So you're okay with everything I did so far. This is what you did in the exam, right?
Yes, sir.
Okay, cool. So next up, we have two binomial expressions. So we need to expand that. So to expand that, I'm going to put the arrows. So that's going to be 5 by A, and then 5 by root 5, then minus 2 root 5 by A, and minus 2 root 5 by root 5. Alright? So that's going to be, it's going to be 5A plus 5 root 5 minus 2A root 5. And where's root 5? I'll take my time. I don't want anybody to get lost.
Minus 2 by 5.
Yeah. Right? They really bring some nice algebra questions this year, boy. Let me look to see if we can simplify anything, right? So 5A, can't do anything with that. Really, just yet. And then I'll have 5 root 5. Okay. So I have 5 root 5. 5 root 5 is an example of a what? Starts with C. Starts with C. Is that constant, right? And is that constant?
Yes, okay. Yes.
Right?
I was thinking of it more as a variable. No, it doesn't have any unknown.
No, that don't have no unknowns in it. Right, so I could write minus 2A root 5. So all of these are A terms. Then I have plus root 5
root
minus.
5, yes.
So that will be plus 5 root 5, right, minus 2 by 5. So we have 10 minus 3 root 5. So here what we're trying to do. We are trying to get the right hand side in this exact format so we could equate. That's what we want to do. That's why I see it. And so that's going to be 5A minus 2A. So you realize we could factor out the A there. Let me see what happens if I factor out the A. For that, I'm going to be 5 minus 2
root 5.
right? And this is going to be plus 5 root 5 minus 10.
Minus 10.
All right. Okay. So then what could do on both sides. So I have 10 on the left hand side and I have minus 10 on the other side. Or does it make sense?
Divide by 5 minus 2 root 5?
You're thinking to divide by 5 minus 2 root 5. Why are you thinking to do that?
You will separate, you will get the a by itself and then be a plus 5 root 5 minus 10. And then put 10 minus 3 root 5, you could rationalize that to get the new sin.
I
And
do.
work to get a.
I feel like I wouldn't do that.
What you would have to say?
So I want to get all the constants over here, and I want to get, well, you see both of them is constants, right? But I feel like I want to have root 5. I want to factor out root 5. So like I'm gonna try something. So I have 5a here. I'm gonna try something. 5a minus 10, and then I could say if I factor out the root 5, from that, that's gonna be 2a minus 5. Okay, so look at what I'm doing. Again, what I'm doing is I want the left hand side to be in the form of the right hand side. So I say in 5a minus 10, and then I'm factoring out a negative root 5, right, from both of these. If I factor out negative root 5, over here you're going to have 2a, because 2a by minus root 5 is minus 2a root 5, yes or no?
Yes.
And minus root 5 by minus 5 is plus 5 root 5. So in doing this, I want you to recognize something. So I could write this like that. Check this out, right? So can we see that the left hand side is in the exact form of the right hand side? Yes or no?
Yes.
Yeah. So the 10 would be equivalent to 5a minus 10, and then the minus 3 root 5. So I could just say 3 root 5. The reason I'm saying that is because, like I said, this, check it out. It literally not different from anything. Like watch, 10 is that, and 3 root 5 is this.
Just substitute 5a minus 10 is equal to 10.
Yeah. This is what I would do. And so I would say, I would form two equations, and I would say 10 is equal to 5a minus 10, and let me check out the other side, right? So we'll have so if I let that be equal to each other, the other term will be 3 root 5, and 3 root 5 will be equal to 2a minus 5 root 5. And so I can divide both sides by root 5 here.
Yes.
If I do that, I'm going to end up with 3 is equal to 2a minus 5. And so I could move across the 5 here. So 2a would be equal to 3 plus 5. And so I could say 2a is equal to 8. And over here, what am I going to say what am I going to say a is equal to?
10 plus 5a is equal to 10 plus 10.
Right, so 5a is equal to 20. And so a will be equal to 4. And watch, a is equal to 4 here as well. So bad that is?
Yeah. So wait, all I have, so get a is equal to 4, but all I had done was I divide the first, I just divide by, scroll up a bit, I believe it was the next, yeah, I just divided by 5 minus root 5, and I get a plus root 5. I got 4 plus root 5.
Oh, well, you'd have thought about it differently. But you understand what I did here, right?
Yes.
I literally, with these kind of questions, you want to get it in the exact same format on the left side and on the right side, so you can equate terms. This is like it's like an advanced level technique. But you see, no matter how I find a is supposed to be equal to 4, right? A is supposed to be equal to 4. Yeah. You think you'd
I still get the full marks.
Yeah, you'd still get the full marks. When we finish with this, you go record your session. You go record your working on a piece of paper and send it to me. Yeah. I want to see where
See, you want to see my handwriting? I fear for them people who correct my paper.
I might be scared as well. So your answer for A is 4, right? Cool. Let's move on to this question. So section 2.3. Using the grid below, draw the graphs of sine 2x and cos 2x. So inside there, we have angle multipliers. Anytime you have angle multipliers, you're going to compress the graph by that factor. So your graph is going to be squished by a factor of 2.
2.
Yeah. So like, this is what I mean, right? If I were to draw the regular graph for sine, it will look like that. Yes or no? Because
not like that, but something like that, yeah.
Because it's between 0 and pi. And because think about it, to draw the full graph, enter would need to go from 0 to 360 degrees, which is 2 pi.
Yeah.
And so that you see why I say it will look like that. Because we're drawing the graph from 0 to pi there, 0 to pi here. Yeah or no? I don't think you've seen it.
Oh yes, of course.
So you realize that this is the graph of sine x. This is how sine x would look like between 0 and pi. But if you had sine 2x, what's going to happen is it will get
smaller. So and it'll pass through pi on 2 and then reach pi.
That is what sine 2x could look like. So how it does work?
I really messed up by not reading that scale by the way.
And so you understand that understand this. If you have sine x requires you to put in 2 pi or 360 degrees to complete a full cycle. But by you saying 2x, whatever angle you put in, you're multiplying that by 2. And so for the range 0 to pi, that would give you the equivalent of sine x. Yes or no? Because think about it. Because I'm multiplying whatever angle I put in by
2.
Right, so if I put in 0, well, that wouldn't change. That'll be sine 0, right? And sine 0, sine 0 is 0. Right? And then if I put in pi into that, and I'm going to end up with sine 2 pi.
Yes.
Yeah, and then sine 2 pi with... You understand what's happening, right? That's equivalent to going a full revolution. But here what I'm saying, a lot of people would have panic and they would have forget how to use the Casio. Even if you forget how to sketch the graph, look at what they could do, right? Look at what they could do. So check this out. Check this out real quick. So on the Casio, let me deal with sine 2x first. If you wanted to get points, you could have plug in, you could have say x is equal to 0 to find out what y would be when x is 0. So in the Casio, you could plug in 0 into sine 2x, and that will be sine by 2 by 0, and that will be sine 0. And so that your first point for sine gonna start at 0, 0 over here. So Amy, if you're looking at this video, this is directly for you. Okay, let me just say we wanted to figure out
another plug your girlfriend, so sir.
What is it?
I say really have to plug or shout out to your girlfriend, so.
No. Amy is my student. She didn't do the graph properly. She forgot.
I might have to you up there. Sorry, sir. Sorry.
Hey, next time hey, if my girl watching this, she'll be saying, boy, you horning ma.
No, but sir.
Hey, oh God. Nah. Hey. So we understand that we have a 1 point. Let's find for another point, right? So we could plug pi over 4 into sine. So when x is equal to pi over 4, and since we're dealing with pi, we're dealing with radians. So whenever you're calculating anything here, you want to make sure your calculator is in radians, right? So
yeah. So you know have to remind fellas to change back to degrees for the Kev exam.
Oh, it wouldn't the only time radians will screw up is when you're dealing with trig ratios. So like if you're saying sine something. Yeah. That your calculator will work completely normal in radians. The only time it will start to work differently is when you have to find sine of an angle. Sine of an angle. So if you didn't know that, now you know.
Oh, so I could have saved my voice, however I used it.
Right, so here what, let we plug in different values for x to see what we gain, right? So let we plug in x is pi over 4 into sine 2 pi over 4. Tell me what you get.
Alright, just now. Calculator beaten up. Sine 2 by shift pi over 4. I'm doing this and write down my calculator in degrees.
Oof. So when x is equal to 0, we got y is equal to 0. So the first point is 0, 0. Right? When x is equal to pi over 4, the function is equal to 1. So y is equal to 1. So my other point is pi over 4, 1. And so Amy, this is what you can do. You can plug in values for x to find the y value and to get points for the graph. So this point here will be pi over 4, 1. Let's try another point. So let me try pi over 2. So if I say x is equal to pi over 2, that's going to be sine 2 by pi over 2. And that's going to be sine pi. Right? Sine pi.
Yeah. I might have drew my way to answer. I read lucky or something because I remember my graph passing through the intercept and then points.
So you got through then?
Yeah, even though I didn't even know one thing. I was right. I just remember the sine graph.
That's crazy.
I didn't even watch this correctly, so I'm telling you. I just passed that route and I was like, that looking right.
That's crazy. You know why? I know why. You probably didn't even pay attention to the scale and you just draw the thing.
I didn't, I'm not telling you, that's exactly what I do. I see one, I say right. I know the side guard customers pass through one as intercept there.
Wait.
So I go just squiggle that thing and make sure in between that one I might have so on.
No,
like,
boy.
Yes, good.
That's crazy. This is one instance where not paying attention what to see here, right? And so since we see in that this is the general shape of the graph, so let me draw it kind of neat.
We get one way we could repeat it.
Yeah, we
Physics students remember.
Right. Right, so we have that there, and so we can figure out the other part of the graph to finish one cycle. So if you didn't know you could do this, drop in the chat, drop in the comment section. Right, this is a perfectly valid method, right? That a lot of people don't know about. I don't know why, but yeah. Okay, good. Let me know if you understand that.
Yes, sir.
And so you understand it's more or less the same thing for cos, right? So the cos graph, since you have a double angle, an angle multiplier, even though 0 to pi is normally wouldn't give you a full oscillation for cos, since you're multiplying it by 2, it come like you're emulating 0 to 2 pi.
Yeah.
And so the graph would look like how the cos graph is normally look like.
Cos graph, yeah.
Right? So let me get some points and do it fast so I can show everybody that it don't matter. Like it don't matter. So it don't matter it don't matter what you're multiplying the angle by, you can always put points to generate some points. So let me run through this fast, right? So Achilles, the first point we could say is x is equal to 0. Right? So if we say in that, that'll be cos 0 and the cos graph starts at 1.
1, 2.
Right?
Cos 0.
Cool, and let's do pi over 4 now. So that's gonna be cos by 2. So the first point here is 0, 1. Okay, let's do another point. So when we say x is pi over 4, they get 0, right?
Yes, sir. Pi and 2 is minus 1.
Right, when you said that, what you get?
3, 4, 0.
You get minus 1, right? For pi over 2. right? And I think, let me see what we could do, right? Let me check out what happened with them points. So when x is 0, y is 1. When x is pi over 4, y is 0. When x is pi over 2, y is minus 1. Wait, I'll be over here, right? So let me figure out some other points, but essentially you see that
It's going that way.
right. So let me do some other points real quick. So maybe we could try 3 pi over 4. So put cos 2 by 3 pi over 4.
Is 0. Wait, is 0? Yeah, 0 on my calculator.
Right? And we get the other point. So let me know if you understood that.
Yeah.
Okay, would. So guys, anytime you see a question like this and you're not sure, you have a Casio, even if you have a sharp, you can generate points. So when you plug an x value into a function, you get a y value. And you can use that principle to generate a bunch of points. So Achilles, isn't this such a goated hack?
Yeah, it is. It's allowing you not to learn tree diagrams.
Yeah, because you have your calculator with you.
Don't forget how you can do this for time graphs too.
Yep.
You just have to remember that thing is a simple.
Oh, drawing this gonna be a pain.
Yeah, that's how you know how it feels. Imagine how it feels for me, sir. I erased that thing so many times. I probably might have start ripping the paper if I keep erasing me.
Alright, so let me know if you understand what that is going to look like.
Yes, sir.
Okay, would. Right? And so let me explain part 2 now. Part 2 says, hence or otherwise, solve the equation sine 2x is equal to cos 2x. I need to make something clear. Anytime you're putting two functions equal together, you're trying to figure out where there's an intersection. Or where there's a, where you have, let me just,
equal.
yeah, because imagine I have this graph here, and I have this graph here. At the point of intersection, so let me just say y is equal to, now looking like a positive gradient, so I could probably say y is equal to 2x plus 1. I could say this is probably equal to y is equal to minus 2x plus 1. Actually, yeah, you know.
Yeah, the math students will be coordinate here because they're looking like it's not perpendicular. Perpendicular, yes, perpendicular.
Yeah, so you see, I change it real fast. As soon as I notice that, nah, I'm not gonna get caught lacking, right? So imagine we have those two lines. We have y is equal to 2x plus 1, and we have y is equal to negative a half x plus 1. Essentially, what's gonna happen there is that the graphs will intersect, and at the point of intersection, isn't the x and the y value the same for both?
Mm-hmm.
So enter that point momentarily. This function is equivalent. So enter at that point, this function 2x plus 1 is equal to minus a half x plus 1.
Yep.
Yeah, and that is what happening over here, guys. So anytime you have two functions equal to each other, you're looking out for the point of intersection on the graph. So obviously we sketch this obviously, but looking at it, I think the solution will probably be here. That looking like pi over, so like
8.
this, pi over 8, right? Because that will be half of pi over 4. And so let me check that in the calculator. So how to check it? Well, you're gonna plug that into your calculator. So you're gonna say sine right, so yeah, that's gonna be equal. That's correct.
2 and 2, and now we just change from cos to sine.
That brings more time to that point. You know about complementary angles and tricks?
Yeah, we had to learn a table for that.
Okay, no, you have to learn a table for complementary angles. All complementary angles states is that anytime you have sine and cos, once the angle for both of them add up to 90, it's going to be the same. So watch, let me give you an example. If I have sine 30, that should be equal to cos 60. Yes or no?
Yes, just that. Yes, sir.
Yeah, and in this case, aren't these angles the same?
Yes.
So since they are the same, what two angles would add up to 45? I mean, I just now say it. I just now say it.
What two angles would add up to 90? 45.
No, 45, right? But then you'd have to divide that by 2 to find
So
x.
22.5.
Right, you see? My brain cannot automatically jump into the answer. I don't know why it does do that. But that's one way you could have done it using complementary angles. So that's one of the solutions. The other solution is obviously the intersection. And the third solution I could think of is dividing throughout by cos 2x, and you get tan 2x. You'd find your reference angle. So I'm going to do all those solutions, right? All those solutions. But you see what I'm saying? Once if you have sine A, that would be equal to cos 90 minus A. Yes or no?
Yes, sir.
Yeah, so you could have used that. You could have used that to answer this question because both of them was equivalent. So then 2x would have be 45. And then if you convert pi over 4 to degrees, you're going to get 45 degrees. Yeah, you will. 180 over 4 is 45. Because 180 over 2 is 90, and 90 divided by 2 is 45. You understand what I'm saying?
Yes, I see it. I see how I lost my 4 marks in 40.
Right? It wasn't that hard, right? It wasn't that hard. I'm going to draw this graph better so you could like see the intersection.
So you're sure you can't be writing exams for people? You just take my registration and say your name is like so and so for a little $2,000 and thing.
I don't know, I don't know. So since I know how the graph behaving, I could actually do a better sketch. Tell me if you understand the ratchet I'm doing there.
Okay, yeah.
Right? So like it will show on the dot. Right? And it could put this could be 0. No, that'll be pi over 8 comma 0. No, what I'm saying? That will be some value for y. That looking like, so we have 1, 2, 3, 4. So then this would be, so each one will be 0.25, so this could be 0.75. Around that, if we estimate it. Yeah or no?
Yeah.
Right?
It would be, yes, yeah, okay.
But we really know his root.
So wait, like the fucking that wrong.
Is it?
It's in, no, not the graph. Your iPad saying it's 9:41 a.m.
Oh no, it's always do that. I don't know why, but it's always do that. I don't bother with it. Yeah? Alright, and let me do this one here. So this point over here, this is in between pi over 2 and 3 pi over 4. If all they don't know how to read the graph, let me show you a little trick, right? You could say you could add pi over 2 and 3 pi over 4 and just divide that by 2 because this is in the middle of pi over 2 and 3 pi over 4. And you can do that?
I myself learning that, sir. Wait, yes, the half is the difference. Yeah, okay.
And so 5 pi over 4, I would just
5 pi over 8.
5 pi over 8. I could just multiply that by a half, right? I could just multiply that by a half. 5 pi over 8. So then this would be 5 pi over 8. And again, this looking like this could be minus 0.75. This could be 0.75. So I never look at any solutions. I never do this test before. It's the first time I do it as well. Right? But I want to explain the concept behind each question, not just solve it.
So the people will say you're lying because they make the go on and work and clean up the test paper.
Well, yeah. I do that, but I never solved it.
I didn't work out the questions.
The
question that right there. He
Yeah,
only make the paper look presentable. He didn't work out the question. All right, guys.
and I never work out the questions. Like actually, I never work it out. The first time I'm working it out, right? And we could check if our answer is correct. So we could put sine 2 by 5 pi over 8, and then we could plug that over here. And for both cases, we're supposed to get root 2 over 2. So let me try that. Well, if I can get root 2 over 2, check it and let me know again. But you're gonna get the same result. You're gonna get the same result.
Supposed to get the same answer, yeah. Minus root 2 over 2.
Right. So, and tell me something. Root 2 over 2. And root 2 over 2 is like 0.70, like 0.71. Yeah.
I won't read. Yes, again, the same answer for both. Okay,
So-
yeah.
So what I want you to realize, it's gonna make so much sense, it's gonna blow your mind. This is a sketch, obviously it wouldn't be 100% correct. So when x is pi over 8, it's minus 0.75 both. It really supposed to be root 2 over 2, which is like 0.71. If you do it like 100% correctly and you take a real good read off, it's supposed to be 0.71. Yes or no?
Yes.
And this will be negative 0.71. So you see how everything in maths is like linked together. So your answers for x would be pi over 8, comma 5 pi over 8. And if you're feeling unsure, what you can do, you can plug your answers into the function and verify that the left hand side is equal to the right hand side. Again, make sure your calculator is in radians mode. And another thing, you can see it from the graph. This is looking like 0.71 and this is looking like minus 0.71, which is what you would get when you plug it into the calculator.
You choose the 0.75. It would most just at that point in time.
Say that again?
I think people would believe it would be 0.75. They won't be able to tell it's 0.71.
Honestly, me either, right? Because based on this sketch, you can't tell that. You can't infer that. Yeah, you can't infer that. But it's actually 0.71. So you're okay with this question. You see how easily you lost the 4 marks. Okay, let's do it in another method. So I'm going to show you how to do it. Let me just say you didn't see this connection, but you do know.
With just calculations.
Yeah. So remember how I did show you a reference angle and thing?
Yes.
Okay, let me show you how to do it using that approach. So we have, this is the first solution. This is from the graph. So I'll put in down here. This is from graph. Okay, and then this is going to be using reference angle method. I love maths. I really love maths. Maths just so cool. No matter how you do it, once you do something that makes sense, you get the correct answer.
You so often profess your love for maths. I hope you do the same for your girlfriend.
Yeah. I Karen, she like a all pay trip to Tobago for she birthday.
Jesus. Well, yeah, that's one of the show love.
Yeah, I love. I will write a couple letters and thing, and I'll make sure and decorate the room and thing. Don't worry. I love boats.
You know, real romantics away here. Probably have some unfortunate girls here, very jealous.
Maybe.
And probably some fellas vex.
Probably, you know. But
In a relationship, can't be doing that.
let me continue, right? And so you understand that. Remember, with these questions, I would always advise you guys to end up with something end up in a situation where you have one trig and you can solve for one trig, right? Yes or no?
Yes.
And so what I could do is I could divide both sides by cos 2x. And if I divide both sides by cos 2x, I'm going to end up with sine 2x over cos 2x.
Tan.
Tan 2x, right? And this could be 1. And do I have one trig? Tell me, do I have one trig now?
Yes.
And look at what I'm going to do, right? I'm going to say, because this 2x might confuse some people, I could say let y be equal to 2x. And if I do that, I'm going to end up with tan y is equal to 1. And so if I want to find the reference angle, and I'm going to say alpha is equal to tan inverse 1. Yes or no? I don't know anything that's crazy.
No.
Right, so in the calculator, I want you to go and put tan inverse of 1. You should get pi over 4.
Shift tan 1. Yes, sir.
Okay, you can see how this real bad is. You can see how sweet maths is. Right, so let me draw we graph. Let me draw we graph, right? And this is
Alpha is positive or good in the fourth quadrant. Tan is positive in the fourth quadrant.
pi over 2 is pi. Alright, so you understand everything I do there, right?
Mm-hmm.
So our answer will be located in the first and third quadrant. So let me draw my reference angle here real quick. Okay,
I'm seeing madness. Wait.
this is gonna work out so easily, you'll be mind blown. Trust me. Well, let me explain another region for confusion, right? In the question, they're saying 0 to pi. 0 to pi. So you're probably wondering, well, this is a madman. Why he going past pi? Ain't you wondering that?
No, not really. I have my trust in the process at this point.
You see, the reason why we could do this is because and any answer we get, we'll have to divide by 2 because y is actually equal to 2x.
Yeah.
Yeah. So we could actually go past that on the graph. So based on what I'm seeing here, my first solution is pi over 4 because I want to figure out where tan is positive 1 and it's valid.
Positive.
So that's valid in the first quadrant. In the second quadrant now, so remember how you do it. So let me just neaten up this thing here.
Everything positive in the first quadrant. In the second quadrant, alpha is pi minus alpha. Theta is equal to pi minus alpha, and the third is 1 pi plus alpha. Yeah.
But wait, you see how it sounded like you remember that. Guys, you don't have to remember it. You don't have to remember it. The reason why you don't have to remember it. Okay, watch this. This come like I went from 0 to 180 degrees, right?
Yes.
Which is really 0 to pi. I went from 0 to pi radians. Yes or no?
Yes.
And how much extra travel?
Alpha. Or pi on 4.
Right. So you don't need to remember a single thing. You could look at that and figure out it's pi plus pi over 4. You could look at that and figure out it's pi plus pi over 4. Understand?
Yes, sir.
So your values for y is going to be equal to pi over 4, and then the other value for y is going to be pi plus pi over 4, which should be 5 pi over 4. Yes or no?
Yes, sir.
And remember, y was equal to what?
2x, so you have to divide by 2.
Badness. You already see how we're going to get the answer. You already seeing it. Right? And so by the way, this is pure maths, eh? You're like learning this in pure maths. In unit 1. And so I would divide, and this could make more sense for most people. I could just multiply by a half on both sides. So on the left hand side they're gonna be just x, and the right hand side they're gonna get pi over 8. And you're gonna get 5 pi over 8. Yes or no? Is that the same answers?
Yep.
We good?
Very good. Wait. 4 marks, right?
And there's another method you could do to work this, which is using the complementary angles. You just state the theorem and say that. I could probably show it fast. So you had to state the theorem, right? You would have to say that if you have sine A is equal to cos A 90 minus A, they will be equal, because in this scenario I'm saying that the angles add up to A, right? But in this case,
add up to 90. The angles add up to 90.
so you're gonna say 2x plus 2x, and that has to be equal to pi over 2. And so 2x plus 2x is 4x, and 4x is equal to pi over 2.
It will be pi over 4.
right? And if you divide throughout by 4, you're gonna get
No,
pi over.
8.
Watch that. Boom. Boom. Way. Badness, eh? Badness, eh? Tell me that is not badness.
It is. Oh my god, I messed.
Yeah.
It's amazing though. It's amazing.
Yeah.
Maths.
Genuinely insane how much ways you can do the same thing in maths. Right? Okay. So let me move on to this. Using an appropriate double angle formula, I think they mean to say compound angle formula, derive the identity for sine 2x. I looked at this last night. So,
I'm pretty sure I get this correct just because the crash course you do, I remember you deriving this and I was just like, yeah.
And I tell a little I was coming. I tell a little I was coming too. I tell a little I was coming, right? So if you have the double angle formula, sine a plus b, and guys, I don't have a reason to get that wrong, eh? Because it in the formula sheet, like it in it, guys, it in it. So you can't get that wrong. So, sine a plus b, that's gonna be equal to sine a
cos b
plus
cos.
And so in this case, we're seeing that both of the angles that I'm adding are the same. So x plus x. And so that's going to be equal to sine x cos x plus cos x sine x. And on your left hand side, that's going to turn to 2x nth. And over here, you have sine x cos x plus cos x sine x. Now, I need all to realize that multiplication is commutative, right? Imagine you have 5 by 4. Isn't 5 by 4 the same thing as 4 by 5?
Yep.
So I have sine x by cos x. I'm going to leave that as is. And over here now I have cos x by sine x. And I could write sine x by cos x. Yes or no?
Yes, sir.
And so on the right hand side, you're gonna end up with 2 sine x cos x, and that's it. Bam. Easy to max. They're saying, hence prove the identity 1 plus sine 2x over sine x plus cos x is equal to sine x plus cos x. Now this probably mess up plenty people. Did you get it correct?
No.
Okay, let me show you how to do it, right? You're gonna be mind blown. The first method I'm gonna show you, I'm gonna utilize what they wanted, right? So what I could do is, and I could replace sine 2x.
The sine 2x one time.
I can say 2 sine x cos x. Alright, and then I could say sine x plus cos x. Okay. And look at what I'm gonna do, right? Remind me, what is 1 equal to? What's the fundamental identity that you need to know?
Which one? 1 is equal to sine squared theta plus cos squared theta.
Right, so I'm going to replace 1 for sine squared x plus cos squared x. Now this is real hard to see, I'm not gonna lie. I show a couple of my friends in UE and they could not see it. And then them doing electrical engineering. Well, I do electrical engineering, so now I see it, but it take a little while to look at it and see it. You remember in the crash course or the marathon, I was telling earlier sometimes you had to factorize quadratics with array.
Yeah.
Okay, well this is one of those situations. Watch. If I have sine x plus cos x by itself, and that will be sine x plus cos x squared.
Yep.
But if I expand that, and that's gonna be equal, let me expand it together, right? And for those who confused, I'm gonna draw the arrows. I don't wanna lose anybody. Alright, I don't wanna lose anybody. So sine x by sine x is sine squared x. Sine x plus cos x is sine x cos x.
Cos x, yeah.
Right? Cos x by sine x is sine x cos x. Cos x by cos x is cos squared x. So I think you've seen it, I think you've seen it. I really think you've seen it.
That entire top formula is just sine squared x plus cos squared x.
Yes, sir. Yeah. So that
So you could
whole
have changed that whole thing to sin x plus cos x by sin x plus cos x over sin x plus cos x.
bam.
On one of them would cancel.
Yeah.
Oh my
Yeah. So that entire top just simplifies to sine. If I factorize it, it'll be sine x plus cos x by sine x plus cos x. It's crazy, right? Like, it's genuinely crazy. It's genuinely insane. And so you're clearly seeing it now that this would cancel off with this. And so you remain with,
Your right hand side, you get your proof.
yep.
QED, your square box.
And it
Whatever
wasn't
else you gonna do.
and it wasn't that much working either, right?
No.
But it was hard to see. I'm not gonna lie. I should have do a quadratic example with all it, but I really should have. I really didn't think it was gonna come, you know. I really didn't think it was gonna come, but it did come. And I was saying I was gonna raise a change with all it too, but I was thinking to myself now, but that wouldn't come, and it come. That's crazy.
So I know about that research change question because I get real trouble with that and I see how I get that wrong and I vex.
I can't wait to do it with you. It's so easy. Like it's so easy.
Yeah, but I didn't even, I read over that question and because I worked myself up in the exam, I couldn't process that information proper. And I sit down at home and when I get that paper, I was just like, wait, this was really easy, you know, but basic one thing.
Chain rule.
Mm-hmm.
Well, I never look at the solution, right? Like, again, I doing this for the first time, but obviously when I was redoing the paper, like retyping it, I see the question and I was like, yeah, chain rule, easy thing, chain rule. So you see, this is one method, but this is not the only method. And at MathVybes, we don't just look at one method; we look at all the methods we could possibly look at, because all students would think differently. And so I would say that this is the harder approach. You want to say an easier method?
Of course, sir. I like easy thing.
So watch this, eh? This is what I personally did. This is what when I solved it and I got through. This is what I personally did. It's only after I realized that this was this. That's to tell you. It's not so obvious to see. So what I did was, if you look at the right hand side, aren't you trying to get sine x plus cos x?
Yes.
Yeah, so what I'm going to do is I'm going to multiply the top and bottom by sine x plus cos x. Probably thinking, nah boy, pressure ain't. Real pressure.
No, I confused how we gonna reach.
Oh, just trust me. It's bad, real bad. You're probably wondering, well, how I see this, but I didn't see descent. I
You put the way with my motor, sir. I see nothing.
I don't know. This just seemed like it was more obvious to me. I could not see it because where else are you gonna get sine x plus cos x from? So I introduced it on the top and bottom. So in the bottom, you're gonna end up with sine x plus cos x by itself. Probably wondering, but what the hell you gotta do next? Huh? Well, watch carefully. In the denominator, I can expand that.
You can.
If I expand that, we know what we're gonna get by now. You're gonna get sine squared x plus cos squared x.
T.
Well, okay, let me write it in that form so I wouldn't confuse anybody. So yeah, if you expand it out, you get sine squared x plus 2 sine x cos x plus cos squared x, right? Look at what I'm gonna do, right? Look carefully. Sine squared x plus cos squared x is what?
1.
And what is 2 sine x cos x?
Sine 2x.
Right, yeah.
Oh my god.
And that would cancel off with the top.
And then you get left with sine x plus cos x.
Yeah, so this is personally how I saw it. I found that the top method was a little bit harder to see. You see it one time with this, and so yeah, you get the answer there. Sine x plus cos x. Bam. Yeah, this was the only hard paper in the. This was the only hard question in the paper.
Good question.
Yeah, tell me.
I'd say this was the only hard question. Oh my gosh.
I find that one and this one wasn't so obvious. Like, I feel like if I was in your position, I would have had to think. I would have be like, you see how like I pause? Because I was like, yeah, it's not looking like it's in the exact form. Well, let me just trust any maths. So, I put it in the equivalent form to the left hand side. I equate the terms, and sure enough, we got a is equal to 4. Right? I find like this was also a tricky question. So far, all the other questions was easy. And guys, I don't have an excuse for not figuring out this one because again, I could have do the thing with the Casio.
Yeah.
Yeah, you could have done it with the Casio. Oh, this one was cake. This one was, oh my god. This one, real cake.
This is when I make a next triple mistake, so.
Oh god. Alright. So
no, I get part 1 correct, you know. That was easy. That was easy.
So we want to find
the
okay, so they're giving us the position vectors A and B. Position vectors means that the vector starts at the origin. So you see in A 2 3 is really O to A 2 3. You see in minus 3 2 that's really O to B minus 3 2. And so if I want to go from A to B, I would have to go from A to O first, A to O, and then O to B.
It won't be OA, sir?
Watch.
Wait, no.
Watch, let me show you something, right?
Yeah, it's the origin. So you start from A to go O, yeah.
And let me show you something. We do not have A to O, but you know what we have? We have O to A. And what do we know about vectors? Okay, so if I know O to A,
just reverse it.
Exactly, you could just go in the opposite direction. Because watch this, right? If to go from O to A is that, right? Because remember, vectors is just position vectors is just coordinates. So if I want to go from O to A, I move some distance horizontally and then I move up some distance vertically, right? So this will be 2 3. Yes or no?
Yeah.
And so if I want to go from A to O, wouldn't it just be -2 -3? You seeing that?
Yes. Wait. I did not in fact cook.
Oh, you didn't cook?
I blinked.
Shit.
I did not see that. I did not draw a diagram.
You didn't need to draw a diagram because this is like regular maths. Like you're supposed to know this. You're supposed to know that if you want to go from A to B, A to O and O to B, this is a triangular rule of vectors, right? This is a triangular rule of vectors. But I'm interested in knowing what you did then. So A to O will become negative OA, right? I could have swear no, you wasn't there for that one. I did vectors. I don't think so.
No, I joined because late.
And
that's why I just say AO and then minus OB. I was like, yeah.
Nah.
This is the thing.
So you're going to end up with -2 -3, right? Plus -3 2. That's gonna be
Yeah.
-5 -3 plus 2 is -1. And so if you want to find a unit vector, the unit vector is given by v hat is equal to v all over the magnitude of v. So this is the formula to find a unit vector. So we're gonna
okay.
Right, the unit vector. So the unit vector is just the vector, the whole vector, all over the magnitude of the vector. So to find the magnitude of, to find the unit vector for AB, that would just be equal to AB all over the magnitude of AB. And you know it makes sense because if I have a vector that's, let me just say 5 units long. Let me just say this vector is I'm doing a quick maths in my head. Let me just say I need something simpler. Let me just say, so stay with me, right? I explained the concept here. Let me just say you have a vector that is 25 units long, right? 25 units long. And we know that the vector is yeah, that's supposed to make sense. That's supposed to make sense. Because 3 squared is 9. Yeah, this is mathematically correct. So, Achilles, if you have a vector that's 25, the length of it now is 25 units long, and if I want to find for one piece of, like one piece of the, on the vector, wouldn't I divide the big vector by 25, so I could divide it into 25 parts? And if I divide it into 25 parts, wouldn't the length for each one be 1?
Yep.
Yeah, so that's the concept there. That's the intuitive concept. And so A to B, we have that's minus 5 minus j. That's minus 5i minus 1j. And now we need to find the magnitude of AB. So to find the magnitude of AB is just the square root of the horizontal component squared plus the vertical component squared. Right?
So minus 5, it don't matter if you plus or minus. So minus 5 squared minus 1 squared.
And you're supposed to get
26.
Right. Right, and that could simplify. Could that break down into anything further? I don't think so, you know. Because it don't have any perfect squares for that. It don't have any, like when you write it as a product of sides, it don't have no perfect square you could use for that. So I think that's, let me just verify. Yeah, just root 26. So your answer is gonna be minus 5i. So let me just resize this. Yeah, so your answer is gonna be minus 5i minus 1j all over root 26. And of course I'll show you how to verify if your answer is correct. So you have minus 5 root 26 I, right, minus 1 all over root 26 j. Yes or no?
Yeah.
Come on, don't want to work. Okay, and if you want to check if your unit vector is correct, just remember the magnitude of it supposed to be 1, right? The magnitude of it supposed to be 1. Yeah.
The magnitude.
So
what's the magnitude, sir?
The magnitude, this is the magnitude. The magnitude is the length. And so you would say the square root of minus 5 over root 26 squared plus minus 1 all over root 26 squared. So do that for me and verify that you're getting 1. And it should work because on top, that minus 5 going to the 25 and that 1 will remain as 1. And so you're going to end up with 26. And if you work out the bottom, you're going to end up with 26 for both of them. So yeah, it just be 25 plus 1 over 26. 26 over 26 is 1. You don't need a calculator for that, but just verify it with the Casio. Verify it with the Casio.
Yes. Squared root 26. And then plus with brackets. One squared all over root 26. I put in this in very poorly. Yeah, no, sir, I put it in wrong.
Check it out. Seeing that? Seeing that is equal to 1?
Yes, sir.
Now you didn't need a calculator to do that, you know, and I can show you that for a fact. What's that? Minus 5 over root 26 squared plus minus 1 over root 26 squared. And anytime you have a quotient and you're squaring it, the top gets squared and the denominator gets squared. So end up minus 5 going to the 25 and the bottom going to the 26, right?
Yes.
Then minus 1 squared is 1. And then root 26 squared is 26. So you have the same denominator.
1. Oh, wow. Square root of 1.
Bam. And that's how you check if anytime you want to check if your unit vector is correct, the magnitude of it is supposed to be equal to 1, right? So let's find the angle of AOB. So let me show you, right, what that means graphically. And you see this?
I draw my diagram for that, so I know what that was graphically.
This is where it is. So on the graph, this is how you would go from A to O. I mean O to A, and then this is how you would go from O to B. Well, not really, right? Because O to B is minus 3, 2. So that'll be something like minus 3, 2. That'll be somewhere like over here. Not really, would be something like this. Yeah or no? And the angle would be here.
Yeah.
So let me just do a little sketch so I don't confuse anybody. I don't want anybody to be confused. My mission is not to confuse anybody. So the first point is 2, 3. So like this could be 2 and this could be 3. So that will be A. Make sense?
Yes, sir.
And then the other point is minus 3, 2. So that's going 3 to the left and then 2 down. No, 2 up, because it was positive 2. Yeah, it was positive 2. So that's 2 up. So 2 could probably be right here. Right, and that will be B. And you could clearly see what they're talking about, right? Because this is O. And so AOB, that's the angle in the middle. 100?
Yes.
Right. And so to find the angle, that's going to be, so AOB is going to be equal to is the dot product of, yeah, it was the dot product of A and B, so that'll be OA dot OB all over the magnitudes of OA by
OB.
Right. To find the dot product is quite simple. The dot product is just the horizontal components by each other plus the vertical components by each other. So like you see how we have 2, 3 and minus 3, 2?
Yeah, multiply.
Right? So that's gonna be
minus 6 minus 6.
Oh, you know what that means?
What?
Wait, oh, also, this is supposed to be cos theta. Yeah, I'm not seeing that. Right, so this is supposed to be cos AOB. Or you could just write cos theta so I don't confuse anybody. Yeah, this is supposed to be cos theta. Anytime your dot product is 0, that means the two vectors are actually perpendicular to each other. So what I really mean is, if you draw this perfectly, it's supposed to be 90 degrees in the middle. Yeah, if you draw it perfectly, you'd see it as 90 degrees. Yeah. So if I were to draw the graph perfectly, it's supposed to be 90. Anytime your dot product is 0, it's perpendicular. Right? So let me work this out. So when I find the dot product, I'm gonna say 2 by minus 3, right? Plus, so it was 2 by minus 3 plus 3 by 2.
3 by 2.
Right? 3. Do we really care for the denominator?
Nah, you don't get 0 in the numerator.
Right? But we're gonna find it anyways because we don't want to risk it, right? We don't want to risk it. Right? So to find the magnitude of O to A is just that would just be the square root of 2 squared plus 3 squared, and O to B would be the square root of minus 3 squared. And you need to put it in brackets, guys, because if you say minus 3 squared, that will be minus 9. So make sure I put the brackets, minus 3 squared plus 2 squared, and so that's going to be equal to the square root of 4 plus 9,
4 plus 9, 13.
And this is going to be that's going to be the same thing. So that means both of them have the same magnitude. Both of them have the same length. Right? So you're going to end up with root 13 by root 13, which is just 13. But you don't need to simplify that because Actually, let me simplify.
I get 0 when you took already.
Yeah, but we're going to simplify it anyways. So we have cos theta is equal to 0 over 13. So cos theta is going to be equal to 0. And if you find, and watch it, if you find
theta,
where you get for the cos inverse of 0?
90. Well, you will get pi on 2 since I in radians.
Yeah. You see, with these questions, they don't specify for radians or degrees. So technically, you could put it in any way. Wait, no. What's it? If you read the question, it will say in degrees. You will see in degrees. You're clearly not reading the question. So you have to put your answer in degrees, right?
Yeah.
So yeah, if you drew the diagram perfectly, you will see the 90 degrees relationship between vector O to A and vector O to B. So in part 3, they say hence state the relationship between the vectors, right? So since OA dot OB is equal to 0, the vectors are perpendicular. Right? And additionally, for the top part, I'd advise you to put the final answer in the form that they want. So I would advise you to say OAB. So say therefore, OAB is equal to 90 degrees. Just to be as correct as possible. Right? So we good?
Yes, sir.
So you lose chunks. You lose chunks of marks over here.
Yeah.
Let's move on. So calculus now. Differentiate the following expression with respect to x, simplifying your answer. Now, in this question, do you think you have to do the full version of the chain rule to get sine 4x? To differentiate sine 4x? No, because it's involved with something else. So if I differentiate sine 4x using the shorthand version, you differentiate whatever is inside the brackets. So if I differentiate 4x, that's going to be?
4.
If I differentiate sine, I'm going to get?
Minus cos.
No, if I differentiate sine, I get cos.
The cos?
Yeah.
Yes, that's why the integral is minus cos.
Wait, I watch. When where's the integral of cos? If you integrate
minus sine.
No, when you integrate cos is sine x.
Because sine x.
I'm not losing my mind, you know. I promise I'm not losing my mind. That's you wanna know how I remember it? So like, I don't know, back in my era, like Snapchat was a big thing. And so how I used to remember it is like for dy dx is SC. So like S to C. Positive. Yeah. And it makes sense to, you know, watch this, right? Watch this. It will make plenty sense for you. So I'm saying that when you differentiate sine x, you're gonna get cos x. So obviously if you integrate cos x, you're supposed to get back sine x. Make sense?
Mm-hmm.
So I'm guessing you lose some marks here.
Yeah. This is where I was stupid math. I could do the differentiation, you know.
Yeah.
I probably need 1 mark because I differentiate the 3 over x to the power 4 here.
So we had to recognize that over there. So if we rewrite it, that's gonna be sine 4x plus 3 by x to the power minus 4. Since when you're differentiating, you need everything to be in the form ax to the power n, and so you take the denominator and bring it up to the top, and the sign for the power would change. And so we can differentiate that now. So you would take the minus 4, you'd multiply by the positive 3, and you'd get minus 12. And then you're going to subtract 1 from the power, and that's your answer.
Mm-hmm.
Yeah.
I get that mark there. If I get marked separately, I get that back.
Well, yeah, you'll get 1 mark. You might get like a 1 mark. Right? And if we wanted to, let's just say it was crazy, right? And you wanted to flex your knowledge. Remind me, how would you integrate sine 4x fully? So like, let sine 4x be equal to, what do you want to call it? You can call it anything.
Yeah.
So we could say a is equal to sine 4x. Why not? You understand I wouldn't say is equal to y, because y is equal to sine 4x plus 3 over x to the power 4. So you'd have to let it be equal to some other value, right? So if that is the case, I would say let a be equal to u, and so what I was saying, I would say let a be equal to 4x, and if a is equal to 4x, no, what am I doing, boy? I'm losing my mind. You would say that u is equal to 4x, and if u is equal to 4x, a will be equal to sine u. Yes or no?
Yes.
Right, and then you would find for du dx real quick, and du dx could be equal to 4, and this could be a with respect to u, so that'll be dA du, right, dA du, and so dA du, that would be cos u, and to combine different rates of change, you would use the chain rule, which says that dy dx is equal to dy over du. Well, in this case, it's not going to be dy dx, it's actually going to be dA dx, right? You see that? Yeah, because we had let it be equal to a, so dA dx will be equal to dA du, right, by du dx. Wait, no, that will be dA du. Do I have dA du and du dx?
Yeah.
Right.
dA du cos 4. When just cos.
Wait, something is suspicious. So dA dx, that will be equal to, oh no, this
focus.
no, this is correct, because the du and the d will cancel off, and that'll be dA dx, right? So we're good. I just have trust issues. So that will be dA du. We know that dA du is cos u, right? We're multiplying that by du dx, which is 4, and so that's going to be 4 cos u, and what did I say u was?
Sine 4x.
Right, so when we do the shortcut, do we get 4 cos 4x?
Yeah.
Okay. Alright, part B now. Determine the coordinates of all the stationary points of the curve. So
I don't know how I get this correct, and I didn't check over. I feel I didn't check over because I get this correct. Do the previous question very wrong.
Well, let me see how it does go. So anytime they see stationary points, right? At the stationary point,
is equal to 0.
Right. When you talk about stationary point, you're talking about like the point where the tangent to the curve is 0. So the gradient will be 0 because it's like a flat line. It's a perfectly horizontal line. Right? The tangent will be a perfectly horizontal line. So let's find for dy dx, right? So anytime you see stationary points, that means dy dx is equal to 0, right? And so you're going to differentiate the function y with respect to x. So you're going to multiply 3 by a third. What's 3 by a third?
1.
Right, so that's going to be x. You're going to take away 1 from the power. What's 2 by minus 5 over 2?
Wait, I'm not paying attention. X squared, 5.
And that would just be 5x, right? And if I differentiate 4x, what am I going to get?
4.
Right, so I feel like some people would get confused with how I do it. So guys, when you differentiate, you're multiplying by the power with the coefficient, and then you're taking away 1 from the power. 3 by a third is just 1. 2 by minus 5 over 2, the 2 and the 2 will cancel off, so that leaves 1 minus 5. So I hope nobody was confused by that. And then I'm going to put a equal to 0. So 0 is equal to x squared minus 5x plus 4. What do I have to multiply to get back? What do I have to multiply to get back x squared? And x by x?
Yep.
And to get back 4 is 1 by 4, but I want to get negative 5, so I will say negative 1 by negative 4, because negative 1 by negative 4 is plus 4, and if you add it, you're going to get minus 5. We good?
Yep.
Right, so x will be equal to 1, and x is equal to 4. Right, and then I'm going to plug the x values into the function to get the y value, because that function tells us directly what y is with respect to x. And so when x is equal to 1, y will be equal to a third by 1 cube minus 5 over 2 by 1 squared plus 4 by 1 minus a half. Awesome. And then we are going to say y is equal to a third This is now when x is 4, so I'm going to replace the x for 4 this time.
Yeah, right.
This is the only annoying part, to plug it in now. So for the first one, you're supposed to get y is equal to 4 over 3.
Yeah.
And for the second one, let me see what we get. Supposed to get minus 19 over 6.
Yeah.
Right, so these are the answers they got in the exam.
Yep.
Pick up you. So after we finish with these solutions, you will count and you will see how much marks you lose. Right, so those were your stationary points. Let's look at it in an intuitive manner, right? An intuitive manner. When enter verify, tell me if I'm doing trippiness, right? Or tell me if you understand it. Enter quadratic, just cut the x-axis at 2 points because it's a quadratic to the power 2.
Yes.
So a cubic would cut the y-axis supposedly at a most of 3 times, right? And so this is what a cubic would look like. So a cubic would have two points, either a maximum or minimum. Let me just say you forget how to find the nature of stationary points. Let me just say you forget that you had to find the second derivative. And you could do a sketch of these points and see which one is the maximum or the minimum.
You can. Yes.
So just by looking at this, which one is the maximum and which one is the minimum? Which one has the bigger y value?
1. When x is 1.
This is the maximum, right? Because it has the bigger y value. This one would, so that point would go up to 4 over 3, and this point would go down to minus 19 over 6. So this would be the maximum, and this would be the minimum if it was a graph it. Yes or no? Make sense?
Yeah.
Right? So hence determine the nature of the stationary points. To find the nature mathematically, you find the second derivative. So we have to find for d2y dx squared. I did that real fast. D2y dx squared. So we have dy dx. Dy dx is equal to x squared minus 5x plus 4. If you differentiate at a second time.
Minus 3.
Right. 2x minus 5.
2 by 1 minus 1, yeah. 1 and 4 over 3 is a maximum. Negative, so it's maximum.
Right.
2 by 4, yeah. And the next one is positive.
So you see that's quick sketch.
Yes. It work out. Recovery, maybe. Something like that.
Maybe. So we're going to plug x is equal to 1 into that. So that'll be equal to 2 by 1 minus 5. 2 minus 5 is minus 3. Right? And so since d2y dx squared is less than 0, the point 1/4 is a maximum. Right? The way to remember it, if you're less than 0, your rails are the crying. Right? And so yeah, it's a maximum. Right, let's plug in 4 into that real quick. Are we nearly there? Hopefully. And we have x is equal to 4. And that'll be 2 by 4 minus 5. That's 8 minus 5. 8 minus 5 is 3, right? And so, since d2y dx squared is more than 0, the other point, which is 4 minus 19 over 6, is a min. Right, so those were your solutions for that. Right. let's keep moving on. Okay. 5 marks for this is key. Let me show you how you're supposed to do, right? So get the question and read fast. Quick read.
The length of each side of a cube is increasing at a rate of 0.25 centimeters per second. Calculate the rate of change of the volume of the cube at the instant when the length is 8 centimeters. Oh my god.
No. Like, I gonna show you how simple this thing is, actually.
No, sir. I know how to do it now, and it's because I know how to do it now. I'm vexed, I'm beat up.
So, yeah, because it genuinely not hard. So they're saying that the length...
It's a few lines away, and it's just like 3 or 4 lines and you get your answer.
Right? So they're saying that the length of each edge of a cube is increasing at a rate of 0.25 centimeters cube per second. 0.25 centimeters per second. So what they are giving you there, they are giving you dl dt. They're giving you dl dt, and?
Yes.
So they're giving you the change in length over the change in time. That's what it means. 0.25. So how I show my students, I just tell them look at the units. Honestly, just look at the units. It will give you everything. Calculate the rate of change of the volume. They want us to find the rate of change of volume. Everything changes with respect to everything changes with respect to what?
Volume.
Time.
Yes, time. Oh.
So that's gonna be dv dt we're trying to find for. And so watch this, check this out. Check this hack, it's crazy. So if I wanna get dv dt, right? Watch that. I already have dl dt. But I want you to notice something. Shouldn't v be over here? Shouldn't that be dv over dl by dl over dt? Yes or no?
Yes, the cancel.
So what do you think I should do with dl dt? Well, since I'm at this point, what do you think I should do with dl dt?
Flip it. Inverse.
Actually, we don't need to do anything. No, we don't need to do anything. Because watch.
Cube is equal to side cubed.
No, we don't need to do anything because watch. If I if I decide to differentiate the volume with respect to the length, I would get dv dl, and I would multiply that by dl dt, and so the dl's would cancel off. So we don't have to do anything. I thought it was one of those questions where you have to reciprocate, but nah, it's not that. So this is how I just advise my students to do it. Look at what they give you, figure out the differential notation, then look at what we're trying to find. So we're trying to find for dv dt. So to get dv dt, that will be dv over dl by dl over dt. We have dl over dt, we need to find for dv dl. So let me do that. We're dealing with a cube. Do we know the formula for volume of a cube?
Side cube.
Well, in this case, I'm going to say L cube, right? And so, I'm going to differentiate the volume with respect to the length. And so that'll be 3L squared. Yes or no?
Yeah.
And they're saying calculate the rate of change of the volume of the cube at the instant when the length is 8 centimeters.
When the length is 8.
Right, so that's what...
substitute 8.
Right, we're going to plug in 8 into that. So that's going to be equal to 3 by 8 squared. 8 squared is 64, so that should be 128.
192.
192?
128?
Wait, let me just...
3 by 64, sir.
Oh my god. Yeah. I don't know what's going on. 192. Yeah, because that'll be 3 by 24. Wait, you sure? Not 72? Sure it's not 72?
192. I'll put it in the calculator there.
Okay, yeah, it's 192. Because 6 by 3 is 18. 3 by 4 is 12, yeah. 180 plus 12 is 192, yeah. Right? And we need to put units. Let me show you how we're going to find the units. So if you have volume, we measure volume in centimeter cube, and we measure length in centimeters. So this is, the centimeters is going to cancel off with the centimeters in the bottom is going to cancel off with 1 on top, and so that'll be centimeter squared. So the units for this is centimeter squared, right? You good?
Yeah.
And so then we're gonna say 192, and watch how everything gonna work out, eh? Watch thing. And dl dt, was 0.25 centimeters
Quarter.
per second. And that's supposed to be dVdt. Now tell me something, right? dVdt, what the units for that supposed to be? What we measuring volume in?
Volume per centimeters cube per second.
Let me see if that works out. So notice, instead of centimeter squared by centimeter.
Yeah.
So what is 0.25 of 192?
Divided by 4.
That'll be 48.
48.
And the centimeter squared by the centimeter will give you centimeter cube per second. So are we dimensionally correct? You're a physics student, you should know what dimensionally correct is.
Yes.
Right, we are dimensionally correct. 5 marks. Easy 5 marks. They didn't even bring the trick. We had to reciprocate. Right, so that was good. Alright, a lot of students will get this question wrong. You need to recognize that this here is in the form of
everything is to the power of a half.
right, and that would be in the form, and I rarely do this, you know. I rarely do this.
Yes, you did.
I make sure and tell all you, learn off this. Because this is in the form ax plus b to the power n dx is equal to ax plus b to the power n plus 1 by
1, right,
A.
all over n. A plus 1?
Yeah.
A by n plus 1. Oh.
So there we go.
Yeah, well, I still get it, you know, sir. I still get it.
So let me check it out, right? So that'll be 2x plus 1. If I add 1 to a half, that should be 3 over 2. And then I would divide by 2, multiply by 3 over 2. Yes or no?
Yeah.
And so in the denominator, what is 2 by 3 over 2?
3.
Right? 3. Now if you wanted to be a little extra, right, you could write it in third form back. So check this, right? So 2x plus 1 to the power 3 over 2 is the same thing as 2x plus 1 to the power a half, all raised to the power 3. Yes or no?
Yeah.
And so I could write 2x plus 1 to the power a half as the square root, and that will be equivalent to
2x plus 1 cubed,
right,
all squared, over 3.
So why
Plus C.
should I do? Or should I do it like this? I should say this instead. For most people to see it better, I should say 2x plus 1 to the power 3 to the power a half. Right? I think you can see it better now. So this whole thing would have been square rooted. Right? I think that tiredness suddenly gets to me, you know. You could believe I still didn't get
So
like 8 hours of sleep.
You
I tell you, like, okay, last night I went to sleep 4 o'clock because I was working on stuff for physics, and so as soon as I wake up, I start teaching physics until 6 o'clock, and then I eat some little food and thing, and then I message you a little bit and thing and see if we can do the solution. So yeah, mentally I like here, you know, mentally kind of unstable. You get this answer? Square root of 2x plus 1 to the power 3 over 3 plus c.
Yeah.
You put it in third form?
Yeah, well, I did because I see I might as well go all the way.
Over here we have sine 2x. I did do this as well, remember?
Yes.
If you have something in the form sine ax dx, it will be equal to cos ax, well, minus cos ax, because if you integrate sine, you get negative. So negative cos ax all over a. Or some people might know it as negative 1 over a by cos ax. But it's the same thing, guys, it's the same thing. So let me answer this question quickly. So if I integrate sine 2x plus 5 cos x dx, when I integrate the sine 2x, I'm going to get minus a half cos 2x, yes or no?
Yeah.
And if I integrate cos x, remember that's 5 is a constant. You have a constant multiplied by a function, right? So that's just going to be 5 sine x.
Yeah, I get this.
Right, nice. Don't forget the plus c. Don't forget the plus C, gang. Don't forget the plus C. Right, so there's the answer.
Think out of math, but that's stupid. We'll see, am I?
You forget the plus C?
Huh?
You forget the plus
I
C?
don't think so, no. I think I write that out of habit. I'm pretty sure I write it.
Oh, okay. You see these graphs? I draw these graphs, you know. I real crazy. I real crazy. I draw that.
Yeah. That was so much easy. CSEC, just put some color in the paper. How much money are going to lose here? Probably plenty, but that's okay. You write it up for exams every year.
Exactly. Them could well put a little color in their life, right? So let me read this question here. Figure 1 shows the region enclosed between the x-axis. This is what they mean, the x-axis. The y-axis, what do they mean by the y-axis? They're talking about this.
Your vertical line.
Which is also equal to which is also equivalent to x is equal to 0.
X equals 0.
And if you forget any examined, you could take the simple example and just shift it. Like, okay, so we know this is x is equal to 1. So and if you shift it, and this will be x is equal to 0.
Yes.
Yes. Right? Because a lot of people just have a, I don't know why, but like this can't see that x is equal to x is equal to 0. So what I just tell them to do is, yeah, that will be x is equal to 1. So just continue going down the line. That will be x is equal to 0. Right. So
now to make the x-axis y is equal to 0.
Perfect. Because this could be, like, take for instance, this could be y is equal to 5. This could be like y is equal to 3. And like, that was y was equal to 2, right? That's supposed to be y is equal to 2. And then that will make this y is equal to 0. Alright. So we have a curve bounded by the x-axis. X is equal to 0. And this looking like x is equal to
3.
Right, so all we need to do is integrate that within the bounds 3 and 0.
Yeah.
And we have a very easy expression to integrate to.
Integration equation, yeah.
Real simple thing. So to find for area, you just integrate between the upper bounds b, a, y, dx. So my upper bound is 3, my lower bound is 0. My function is, I think it was x squared plus 2. X squared plus 2, yes. And so if I integrate that, I'm going to put my square brackets and I'm going to add 1 to the power, and I'm going to divide by the new power, which is 3. That's going to turn to 2x.
2x.
I put 3 on top, and we know that you're going to make it real simple for us, boy, because when you plug in that one of the expressions is going to turn to 0.
You just have to plug in the 3, they even have to do nothing with the next one.
Exactly, because when you integrate, you're adding an x term to each term, and so if you plug in 0, whether you
multiply by 0, you get then 0.
Exactly, right? So it don't matter if you're multiplying a constant by 0. It don't matter if you have 0 divided by some constant, you're gonna get 0 nonetheless. Right? So, and I was not about to write 0 here. I was about to write c for a constant. So it don't matter if you have 0 divided by a constant or 0 multiplied by a constant, you're gonna get 0. So really, we just have to say 3 cubed over 3 plus 2 by 3. And if you want, you could always say minus 0. So when you plug that into your calculator, let me work it in my head. You're gonna get
27 over 3 plus 6.
You're gonna get 15. And that'll be 15 units squared. You don't want to forget the unit squared, right? You figured out?
Nah, I didn't.
Okay, good. So this was real easy. Damn. Okay, let's move on to this question. So figure 2 shows a shaded region enclosed between the x-axis, the y-axis, and the curve y is equal to 4 minus x squared. So wait. Okay, them real help all out in this question, boy. Like they make it so obvious, like, you know what I mean?
I'm not seeing it.
People will come at me in the comments and they're gonna be like, this man saying everything easy. Guys, I go admit when something was hard, right? The only question that was hard was the trig question and that area question. It's kind of tricky. Other than that, everything was easy. So part C, we had to find the volume you would get by generating this thing, like rotating it about the x-axis. So imagine you take this shape and you rotate it 360 degrees. That would be given, the volume would be given by V is equal.
The integral of that formula.
right?
Right, pi. So, how come they're using pi? Using pi to represent the constant, but I always find pi is such a fascinating number because it's basically what the closest thing we have to infinity.
No, no, no.
Since the decimal just keep on going.
If I show you the origins for pi, your mind is gonna be blown. Like it really easy. Really easy to derive and figure out. Like it just insane. It literally just insane. It don't go on to like I hear what you're saying, right? It is an irrational number. The nature of pi is irrational, so the decimals keep on going down the line. I that what you mean by infinite?
Yeah.
Okay, because three is not infinite.
No, it is not.
But the decimals go on indefinitely. Yeah. Remember, one of these days I will show you how to prove pi. It's real cool. Okay? And I'm gonna use a pi to prove it. Like an actual pi. And a piece of thread.
Okay then. You're gonna spend $60.
Eh?
You're gonna go mass your price matter whatever and spend $60 on a gear.
No. My girlfriend is a chef. She's actually a chef. Yeah. So I just had a link of the ingredients and bam. Right? I get a pie. Yeah. So let me answer this question, right? I feel like a lot of students would have forgot that you had to say y squared. Please tell me one of those. One of them?
Nah.
Okay.
I find that one time.
Alright. So recall that y was equal to 4 minus x squared. And so y squared would just be the product of this by itself. So what do I mean by that? I'm saying it's gonna be 4 minus x squared by 4 minus x squared. And you would expand that as how you would expand any binomial by another binomial. So that's gonna be 4 by 4. That's gonna be
16. 4x squared.
You know, over the holidays I'm gonna do maths. I'm gonna do like a record. I'm gonna do maths for 48 hours straight. Like no breaks, just doing maths for 48 hours straight.
So you don't think about your health? I want to live a nice long life. That's why I just put sleep up late.
Well, everybody gotta know my name, man. Everybody gotta know my name. You know how like everybody know Mr. Beast?
Yeah.
I gotta be the Beast.
I don't like fame or number. So I go support you, but I say, nah, I don't want to be the fella to say I go for 48 hours, watch the numbers, divided, derived and all that. It's just like, nah. Well, I like just lying down and thing, seeing the sky.
Well, for me, it's more than that. It's more than that. It's like, it is more than that. It's not just the fame. It's have more than that than the fame. Right. So you understand how I expand that, right? 4 by 4 is 16. 4 by minus x squared. Nice. And then you're gonna group together the x squared terms. Imagine you
minus 8x squared plus x to the power 4.
For anybody that don't understand this, let me give all the example, right? Let me just say Achilles take 4 a Nicholas girl, and then you take another 4 a Nicholas girl. You take 8 a Nicholas girl. Now he's birdless. He's a singular matrix, right? So that'll be negative 8x squared, right? Plus x to the power 4. Cool.
Now, so Nicholas, when I come and pelt something at your head, or you gonna do something? You do something.
Nah, Nicholas have plenty to go around, boy. What you saying?
Well, yeah, but Nicholas kind of protective, you know.
Okay. All right.
He protective? No, I will get something called at me.
All right, so here what?
I can't put your name in your body. Nicholas is a good fella. Let's forget about you.
Okay. So a lot of students would have also had a hard time trying to figure out what bounds the area under the curve, right? So by looking at this, you can see that it's bounded by obviously the x-axis.
Yeah.
Right? It's bounded by the y-axis. And it's bounded here. So we're going to pivot it about this point, right? Think of it as a pivot. And you're going to rotate it 360 degrees. So it's between x is equal to 0 and x is equal to 2. You said that, right?
Yeah. Did I? I can't remember.
Please tell me.
Honestly, can't remember.
Yeah, because this would watch. And this.
It's coming out as 0, yeah. So
and that would define the region. X is equal to 0 and x is equal to 2. So please,
Ah.
I'm gonna say 16 minus 8.
X squared plus x to the power 4. We have to integrate that still, answer.
Yeah. Wait, were you asking if we still had to integrate it? Yes, of course.
Yeah.
Of course. You have to.
I'm just making sure because I remember I integrate that as like back this. And this is y squared, yeah, and you have to integrate y squared.
Yeah. I'm happy that I remember that. That's good.
Because I was moving down, I started to substitute when I get y squared. I was like, wait, this wrong.
No, you was doing the correct thing. Right? So now again they make it very simple for us. Making that, and because one of the bounds is 0. Right? So that's gonna turn to 0.
You just have to substitute q into that.
Right? So we're gonna say
and q.
what are we starting to lose our minds, honestly? The maths go take me out, you know, the maths go take me out. Right? Tell you, the other night I went to sleep and my heart racing for some reason, like I'll tell you something. After every marathon, I don't sleep because like I'd be so anxious, like as real wonder what happened to you. Like I'd be like, damn, I can't sleep, you know. Like every time I do something, I'd be like, damn. Whenever these kids go be okay. I just can't sleep. Right? The same way like how your heart beating right now when we're doing the solutions. That's always be. So I'm being extra cautious here. I don't want to leave out any working. So I put the square brackets to indicate that when you're doing definite integration, you would plug in the upper limit and then you would minus it from when you plug in the lower limit. And so I kind of showing that. A little shortcut by showing it, right? Because when I plug 0 into this whole thing going to turn to 0. So that's why I say minus 0. Right? Then in the next line, they can drop it. And so that's going to be 16 by 2 is 32. That'll be 8. That'll be minus 64 over 3. That's going to be 32 over 5. With it? 2. 8. Yeah. Yeah. And almost.
Yeah. So my calculator playing stupid right now. And I don't like it.
Cassie uses never play stupid.
I know, but I fried. And I don't want to type back all this long thing.
Okay, I'll tell you the answer. So V is 256 all over 15 pi units cubed. That's the exact answer. Did they ask for it in the exact form?
No, I don't remember reading that.
Let me see. If the region is rotated about the x-axis through whatever, calculate the volume of the solid form. So they never asked you to do for the exact form. This is the exact form, by the way. So if I round it off to 2 decimal places, I should get 17. I attempted to just call it 17, you know, because it's 17.06. Let me just say we round it off, but even if we round it off to 3SF, you're still going to get 7. I'll just say 17.1. I attempted to say 17 because this is the answer I get in.
Yeah.
But it's 17.1 to 2dp.
Pi, 17.1 pi units.
Yes.
Mm.
Can't forget the pi. Let me multiply by pi real quick. And you'll get 53.61. Actually 53.62 because it's 0.616. Right? And that's the answer. Right? So 256 over 15 by pi. Just verify that. Right? So 53.62. Right.
Yeah.
So you got the answer?
I'm supposed to get my phone mark, sir.
Yes. Alright, so and that tell all you? No, you wasn't there for that, but I make sure and tell all you. No, you was there for that because you usually one that was
yes, I was there for probability. I stay up.
I tell all you, learn conditional probability and learn non-mutually exclusive events. Right? So they gave us A, they gave us B, they gave us C union Oh, this is a nice question. This is a nice question. That's a nice question because you gotta find the intersection first using the formula for non-mutually exclusive events. Wait, this is a nice question, boy. Because if I want to find for the probability of B, granted that A happened, that's going to be the probability of B right, B intersect E. You understand? All over the probability of E. So, remind me. By the way, I have a question also. Does A union B mean the same thing as B union A?
No.
It does. All that means,
Does?
yeah, because think about it. Union is just combining the elements, you know. So like, if I combine A and B, and I combine B and A, and that's still gonna end up with the same thing.
Yeah.
I feel like you don't fully understand it, you know.
No, multiplication is commutative, so anywhere it go.
Well, union typically means addition, no? And union means
And
or.
then I'm not really grasping it there.
Watch this. If let me just say that a bio club, right? A bio club. Let me just say Nicholas and that, and the 8 other birds. Let me just say one starting with S, one starting with T. Nah, let me just give them 3 birds, right? S, T, and G. Right? And let me just say you in this as well. And let me just say have a physics club, right? I in that, you in that, no, Nicholas in that, and you in that. If I combine, watch. If I combine both, and they're gonna be you, me. So it's gonna be you, me, Nicholas, and
the
ST.
other birds.
Yeah. And if I say P union B, and that gonna mean the same thing, I just combining.
Excuse me, dog.
That's
okay, yes, sir.
Yeah, so it don't matter, guys. It don't matter. All union means is just a combination of the elements in 2 different sets. So doesn't matter, right? So that would have confused some people. So we need to find the intersection between B and A. So to find, and again, the intersection doesn't matter either, right? You could write B intersect A, you could write A intersect B. It means the same thing. Yes or no? Because and it shouldn't matter how I write it, because if I have 2 elements and I'm trying to find the intersection what they have in common, so it don't matter if I write A intersect B or B intersect A, it means the same thing.
Yeah, it will still be the same.
So let me use the formula for non-mutually exclusive events to find for the intersection. So for non-mutually exclusive events, A union B would be equal to the probability of A plus the probability of B minus the intersection. You remember me doing this, right?
Yes, sir.
And it come. So like, you got through with it, right? You did this. You didn't just...
Yeah.
Oh, okay, nice. You're smart. You're genuinely smart. And so I would move across this. Remember from yesterday? I move across that. I move
That's
across.
the first thing I do when I see that question. I just write by that formula and rearrange.
Nice. Yeah, because you see the information I was talking about.
Mm-hmm.
Must say you're real smart, and you're real smart. If it wasn't
CSEC, if we say a thing, yes?
If it wasn't for that tricks question or that vector question, you know, I make the meritless.
Right. What was the point of making meritless? That was fella in my class make meritless. He got a certificate and
I know it's kind of disappointing. I make meritless a couple of times.
It's like, look at you, 99, 100%. Congratulations, you get 99 or 100% in this one test.
Yeah, and
forget all the other tests you do in secondary school.
And what are you doing for you in your life?
And then you're any employer gonna be like, you only meritless? Only meritless people could walk in this law firm, you know?
No, nobody does say that.
It's just like, wow. Nobody's asking for that, bro. Nobody gives.
Yeah, nobody cares, right? Like, and I didn't even merit list for maths and odd maths, or pure maths. I merit list for TD of all things, technical drawing.
It's the same, the fella had the same meritless for TD.
I think I come out like third in the Caribbean. I mean, it is impressive to say, like, damn, I come out like third in the Caribbean.
Yeah.
It was, it's not really
Top
practical.
3 in the Caribbean for TD.
It's not really practical, right? So let me plug in
What
now.
you're studying.
Let me plug in our information. Let's do that and find for our answer. So that's gonna be 0.8
0.8 plus 0.5 minus 0.9. They're gonna be 0.4, sir.
So you understand that how I went from this line to this line, it don't matter, right? Because union and intersection, it don't matter how you write it. B intersect A means the exact same thing as A intersect B, so don't let it confuse you at all. So that's going to be equal to 0.4 all over probability of A, which is 0.8, and that should be a half.
Alright.
You get that?
Yes, sir.
Yeah.
Gucci, a good
Nah,
man.
nah, you're bad. You're real bad. But respect for you is like up here. Right? Oh, and we do a question just like this, but way. Nah, boy.
Yeah, I think this
Way.
table so fast.
Way. Nah, boy. I predict the probability good, boy. I was like, where's the probability that... Nah, not bad. So let me do this fast. So yeah, you have to add all the possible outcomes, right? So like, if you get a 4,
4 and 1,
I
5, yeah.
think it have a mistake here, with the copy I did. Let me check the original.
Yeah, no one. Let
Lem-
me check, man. Oh, you're checking.
Wait, no, I keep clicking that one. I don't think I have the original here. Check it for me.
Yeah, I'm checking that, sir. And my
Oh, no.
smart,
Actually, 12. Yeah, check it.
What page number, sir?
This is.
Wait.
Just check the.
No.
This correct?
Is yes, sir. Didn't make a mistake. Is
What?
two. Yeah. Shift that top column. You shift it across. So that 4 is supposed to be a 2. And
Oh
after
God.
that,
Oh God. Wait. Let me just fix that one time. Fix that fast.
if you have your phone and sending you a screenshot of what it looking like.
Oh no, I good. I don't need the screenshot. Right? I know it gonna be. This gonna be 2, 4. Yeah, I know it gonna be. Can't believe I make that little mistake. Right, so this is gonna be 2. It's gonna be 4. It's gonna be 6, 8. A second fair die. So wait. I
2,
got
4, 6, 8, 10, 12.
So
and then is 1, 3, 5, 7, 9, 11.
Alright. Oof. I thinking if I should even put this video on YouTube now. Oh.
Yeah, they recorded, sir. Small thing. Have bloopers.
Yeah. People go think
I should be more relatable to the children study, and then Terry Davis will just watch the question like, yeah, I could solve this. Easy walk. Bloop, bloop.
I guess it's more natural, and all you're getting to see the process behind it from a student as well, because I'm an electrical engineering student. So like, all you're getting to see me do it for the first time and see how I would do it. So they wouldn't feel like, this man is a genius. He know what to do every single time. It's if you study and if you understand the concept, you could get through. You know? Because I don't think I smart.
Yes, I do.
I don't think I smart. I just think that dedicate time to understand the thing, and now I could apply it because I dedicate the time. I don't think I that smart. I think anybody could like become good in maths and add maths something. You just have to dedicate the time towards it and you'll be fine. That's why I truly believe. Because you find this stuff hard?
No, especially when you cross the steps.
Yeah, it's not hard. None of this hard. It's just you gotta understand what's happening. Okay, so this is correct, right?
Yeah, 2, 4, 6, 8, and 12. Yes, sir.
Alright, so this could be 5, this could be 7, this could be 9, this could be 11, this gonna be 13.
13.
How real weird though, how like they skip 11?
They kind of prejudiced. Well, they were skipping a difference of 2 for everything.
Oh, okay, yeah, I see that. No, but what I mean, oh, well, yeah, they do that. I don't realize that. Okay, I don't realize that. For some reason in my head, I was like, oh, watch this.
Yeah.
Okay, I see.
It makes the whole thing.
I see. Oof. So this could be 13. This gonna be 15.
15.
7, 9, 11, 13, 15, 17, 9, 11, 13, 15, 17, 19. This gonna be 11, 13, 15, 17, 19, 21. It's gonna be
13.
15, 15, 17, 19, 21, and 23. Right, so that makes sense. We have it there. Cool.
The whole table.
Yes. Right, state the probability that the sum of the scores from throwing the dice at BI is prime and even. Okay, so let's figure out all the possible outcomes. So the table we had was, let me just count the dimensions, right? So we have 1, 2, 3,
6
4,
by
5,
6.
6. Yeah, 6 by 6 is 36, so we have 36. Right, so for both it's going to be over 36, and we could always simplify that. Right? Okay, the set of prime numbers. Tell me, what are the set of prime numbers? Give me some examples of prime numbers. And what exactly is a prime number? Explain it to them.
Prime number is a number that can be only be divided equally by itself and 1. So 2, 3, 5, 7, not 9, 11. After that
not
is
9,
13.
You say 9? You
Yeah.
said no?
Not 9, no.
No, not 9. Because 3 could go into 9.
Yeah,
Right?
3 times.
So let me do prime. Let me just highlight it. So this is our prime number here. Prime.
11, 7. It had a good view.
So we can just look at the diagonal, right? I don't know if you saw that. You can just look at the diagonal.
17, 2.
Right, and then
Wait,
19.
19 if you want it?
Yeah.
Yeah.
23 is 1, 2. Right, let me just 13. Forget that one there. Right, so just cross check.
It have more sevens.
Right here and here.
2.
And 5. Right, so tell me, not looking like it.
Yeah. 9, 9, 9, 15, 15. Yeah.
This go help it make it more legible. Right?
3, 5, 7, 9, 11, 13, 15, 17, 19, 21 plus 4, 25 in total, 25 over 36.
Let me just double check that. So 3, 4, 5. Right, so 4, 6, 7, 8, 9, 9, 10, 11. Yeah, 11 minus 36 is 25. Right? 25 over 36. Okay. can we? Oh, you may tell you something real cool.
Or the next answer will be 11 over 36. Wait, no, those
What?
aren't even numbers.
What?
No.
Bro, what?
No. Just because they aren't prime will make it even, Achilles.
Yeah. You can't simplify that though. That's as it is.
Yeah.
But like it's squared though. That's like 5 squared over 9. No, 5 over 6 squared. Yeah. I can write that as 5 over 6 squared. Alright, let's check out even now. Let me check out the even numbers.
So, what if it have a madman who write that as 5 squared over 6 squared and still get good?
Yeah, I mean, where they go take away the man mark for, right? Right? So let me look at even numbers.
Even.
So
It already have plenty of that, you know.
it do matter of fact I don't think it have any, because if you're adding let me look at it logically, right? There's something I want to show
It
you.
has to end 2, 4, 6, 8.
No, but let me show you something, right? Let me just say, okay, so n. Let me just say we start off with an even number, right? N represents an even number. And anytime I add 1 to an even number, I'm going to get an odd number.
Yeah.
So I want you to recognize what's happening here. So like we start off with 2. 2 is our what?
Even plus 1.
And 1. So that will be odd. 4 and 3 now. 4 is an even number, but you're adding it to an odd number. That will be odd. And realize it's the same pattern throughout. So I don't think we have any it shouldn't have any. It should be no. It should be 0. Because of the things you're adding now. Because of the things you're adding. Anytime you have an even number, and you're adding odd numbers to it, the result will always be an odd number. Because of that rule I'll show you there. So if you didn't know, now you know. So that's supposed to be 0 over 36, which is just 0. So you good?
Yeah, well. Can't be divided or some mark so dotish.
You lose a mark for that? Where you see?
Yeah, I remember I put a number for that. I put 1 or something.
What? 3, 5, 7, 9, 11, 13, nope. 5, 7, 9, 11, 13, 15, nope. What you see? Nah, that's crazy. Don't have no even numbers there. Alright, let me do the interquartile range now. So they want me to calculate the interquartile range for the stem and leaf. So first of all, we need to count the amount of the data we have. Just make sure I did the diagram correct. Just make sure. Run through it fastly.
0, 1, 2, 2. 0, 1, 3, 3. 2, 4, 5, 6, 1, 6, 6, 8, 9, 9. Yeah, that's looking correct, sir.
Okay, wood. So let me just count it fast. 1, 2.
Wait.
Check
So
it.
it have a 85 and a 92. 85.
Okay, so it's supposed to have a 5 over here.
Yeah.
Okay. So just check it one more time. Make sure it's good.
0, 1, 3, 3, 2, 4, 5, 1, 6, 8, 9, 9, 4, 7, 7, 3, 6, 5, 2.
That good?
Yes, sir.
Alright, so let me just number it. This is 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you have 20 terms. And so if I want to figure out the interquartile range, I need to find for Q3 and Q1, right?
Yeah.
Right, so
3/4, 20, 15, and 5. The 15th position and the 5th position.
wait, is a quarter of n plus 1, and it's 3/4 n plus 1. That's
3/4 at 20, man.
Mm-hmm.
Now between 15 and 16.
Right, so let me check it out. So Q3 gonna be 3/4 n plus 1, and that will tell us the position. So that's gonna be 3/4 of 21. And what you get for 3/4 of 21?
0.75 by 21. Make my calculator off.
Calculator come off.
Yeah.
Can I Casio this man have, boy?
15.75, the cheap one. The 82ES, FX82ES Plus.
Damn,
I spent 150 on this.
that's. Gotta invest in the property. My girlfriend buy one this, you know. But I just show her this for my birthday and she gave it price, man. She's supporting the addiction.
Yeah, she bought in the addiction. She's supporting your madness.
Yeah. So 15.75. That would be between the 15th and 16th term.
Yeah.
15th and 16th.
67 plus 67. So 67.
Right.
5.25, 5 and 6. 42 plus 44. 86 divided by 2.
42.
43.
Oh yeah. I think we said. For those who don't know, the time right now is 12:08. So we starting to, starting to tweak a little bit. But so the badness has go. We're showing real human emotion here. So Q3 is 67 plus 67 over 2, which is just 67, because I mean it's 67 over 67. I mean 67 plus 67 over 2, so 67. And Q1 is going to be 42 plus 44 all over 2.
86 over 2.
Right, which is 43. So we got nice answers, nice. And so we need to find the interquartile range. We're not done. For those of you who would have...
That's 67 subtract 43. That will be give us a nice old 24. Yeah, 24.
So the IQR is going to be equal to 67 minus 43, which is 24, like you said. And if you wanted to find the semi-interquartile range, what do I do?
Divide by 2, and that'll make 12.
Right. Cool. We nearly finished. Good. So just make sure I draw.
So this looking so nice to watch, and then in the test, it was this little microwave thing.
Yep.
I was marking off that scale with that flicking ruler, trying to approximate where Q2 was.
Yeah, I mean you still have to estimate it over here. You still have to kind of estimate it, but I will show you how we're gonna do that. So we want to find a median. So anytime you have a box and whisker, right? This is Q1.
Q1.
This is Q2, and this is Q3. This is your lowest observation.
Highest observation on the opposite end.
Right. And so to find the median, I don't know why I put this space so far. But anyways, to find the median, we just had to take a read off here. What you find out looking like? I would have said
I say 28 or 27. I think I said 28 in the exam.
that looking like 27.5. Let me check. Yeah, that really looking like. Wait. They make it so stupid, but I feel like
that's what I say. I
26,
have to get some
27,
leeway with what they
28.
give me. They have to give me some leeway with this stupidness.
So this looking like 26, 27, 28, 29. It looked like it's 28.5. But I mean, I sure it wouldn't be that critical because I give you a stupid question. Right, it's looking like 20. So Q2 is equal to 28.5. Right?
I show if I have a teacher, I say how you could read off a decimal place from this diagram.
Well, I mean, like it's not like it directly landing. Like I feel like I have nothing I could do.
There's nothing you could do for that. The scale they choose for below it not suiting what they do there.
Yeah, it's really not. If anything, this looking more like 28. It looking closer to 28. Yeah. Alright.
At
Alright.
least the last question was an easy one, the range.
Alright, to determine the range, that will be 10 minus. That's not exact.
75 minus.
No, that's not 75.
75.
That is 74. That is 74. That is not 75. Did you say 74?
My apologies.
So that is 74. So that will be 74 minus 10.
I might have said 75, you know.
And that will be equal to 64. Yeah. Describe the shape of the distribution. So this is obviously positively skewed, right? Obviously.
Yeah.
Obviously. Because most of the data is situated after the median. And so think of a number line. This will be
and
like
it's to the right.
Yeah, and think of a number line. If this is a number line, so this could be negative and this could be positive. This always remember it. Most of the values to the positive, so positively skewed.
That's how I remember it too. My teacher in school, Miss Somati, gone over that like the day before or like a week before. She had mentioned us really learning that. It was, yeah.
Big up Miss Omati. I really love Miss Omati, you know. She's a G. She's a G. We used to talk about maths and all kind of thing. Yeah. Right? So it have a mathematical way to prove it too, right? If it's a positively skewed relationship, that means Q3 minus Q2 has to be more than Q2 minus Q1. I'm not gonna do it because it might take time, but
yeah,
but like
it's rather strictly.
But like it
no,
will
it'll
work.
be easy because I read off Q2 and think easy. Like what the box and what stuff not supposed to do. But
Well,
it's not doing that.
Well, we could always do it, you know, like Q2. We said we assumed that Q2 was 28.5, right? And like I think you can read off Q3 will be trouble too. Q3 looking like that same strippiness. That looking like
You can't say if it's 54 or 53.
So we're gonna say it's 53.5, right? And well, in that situation, it go the 0.5 will cancel off, and I guess it will make sense. I guess so. And this could be 28.5 minus Q1. Q1 is 20. And so on the left hand side, you should get 27.
It's more than 8.5.
Yeah, 27, and that will be obviously is more than 8.5. So this is a mathematical proof to show you positively skewed. Right? 5 out of 30 students in a class were randomly selected, and their heights recorded in centimeters are shown below. Calculate the variance of their height in square centimeters. So the variable here is height, so that's going to be x, right? So when you want to find variance is equal to s squared. S squared is equal to x minus x bar squared over n.
I know something, so you know, I feel, I didn't do that. So you know what I do?
What's that?
I say standard deviation is equal to f summation of x or something. I just add up all that and divide it by the average.
No, you're supposed to put summation here. Thank you for reminding me. Yeah, because because standard deviation is just the square root of variance. So this is the formula that I tell all to learn for standard deviation, and so variance is just that by itself, right? So you did that, right?
I feel like for that, sir.
So we need to find the average. So the average of 1 to the 5. Tell me what is the average between all the terms given?
I'd calculate the average to be 6 points something. And I add up all those terms. That's all.
You get what? I get 143.
What you calculate? How you calculate that split?
So I say add up all. So let me tell you what I add, right? So I say
One
135 plus 144 plus 137 plus 146 plus 153. So I have 5 terms. So I put equal and I divide by 3. I divide by 5. I divide by 5. And I get 143.
153. And then divide by 5?
Yeah, because and we have
Oh,
yeah, because
5 clean. I divide by 6. Oh my gosh.
what? Oh,
Mm,
and they'll get you,
Alright.
they'll get you like 3 or 2 marks. They'll get you like 3 or 2 marks.
I'll be glad if they give me 1.
So x bar is equal to 143, right? And the formula for x bar is equal to the sum of x over n. Well, in this case, because we didn't have frequency, so it didn't have to be sum of fx over sum of n over n, right? So just that. And now we need to find x minus x bar. So let me do that like fast. So to find for here, what I go and find x minus x bar squared one time and done, right? So that's gonna be 135 minus 143 squared.
As minus 12 squared, 144, 1 squared, 137,
Wait,
6
Wait.
squared, 36.
wait, what?
You could,
Watch.
wait, 8? Oh, yes. I mental maths done. That's it for me at mental maths.
I think the people on YouTube go to like we starting to like lose our collective intellect.
Faculties.
Yeah. I feel like you're gonna have some hate comments.
What the hate comments comes to
You know what? Haters
is
just motivate you. Eventually I will have my little army, you know. I'll have my little army.
It's come like them like 3-4 people who does always this like current Mr. Springer and Mr. David's lives. It's just like wow.
Like why
What
you
is
doing?
so
Why you doing that for? They helping you. I mean, you hating on
Cause
people
you
like
know,
you.
that'd be so weird, sir, because you have to go on the man like just to this like is what
Yeah, it's crazy. It's genuinely it don't make sense.
let me start adding this up while you're doing that so you don't have to stay here. Plus 1 plus 36 plus 9 plus 100 210 divided by 5 42
Right? You sure? You sure that correct? Like you check it. Like you're good, right?
64 plus 1
65,
plus 36
101, 110, 210. You get 210?
yeah, and divide that by 5 I get 42.
Yeah, that's correct. So the variance s squared is equal to 42. Cool,
Square centimeters.
right? Centimeters squared,
Alright.
right? Oh, and that's it. So like,
Yeah.
where exactly? Like, you feel you do good in this exam?
I don't know again. I won if I do good in paper 1.
So like, you do good in general.
Yeah.
So the only thing that you lose marks for is So let me.
This, the
So you lose.
the difference, the integration, I mess up.
Wait.
The
So
probability.
let me just say you lose 3 marks here, right? Worst case scenario. I minus
Yeah.
3. You lose. No, you didn't lose any marks here, right?
Yeah, no.
You lose you didn't lose anything here. You get 24, right?
Yeah, I lost mark there.
Here?
I lost 1 mark here. No, in the sample space diagram.
It's a minus
Pretty
1.
even on this. I feel I write something there. Some strippiness.
Think you do this correct?
Yeah, I got these 2 big integration questions correct.
Nice.
Area and the volume.
Yeah. Feel like you do something
I
wrong
got
here.
this
You know?
one correct, yeah.
No, but remember you did tell me And you did integrate sign wrong?
Wrong. The above one, I get wrong.
Okay.
I feel I do that one just wrong.
This one, so let me just say you lose 5 marks for the worst. Then for this one, get that correct. You get
Yeah.
get this correct. This one over here, you lose some marks here. Let me just say
Yeah.
you lose 2 marks. Over here, you probably lose like how much? Like
I think I assume I get this whole thing wrong. Because I didn't reverse it.
revise it. Yeah, we definitely
Revise. I didn't reverse it. I didn't do nothing. I did not cook.
right. And I guess then you
I
lose
put
some.
1 line for this.
So like let me just say -4. You get this. I presume you get that correct.
Yes, I remember that proof.
You get this correct.
I got the graph. I didn't find it. I don't think I get the correct one. So
Let me just say again -4 then. You get this correct. I real surprised you get this
Yeah.
correct. Like big up yourself. You get this correct. R is equal to a
Yeah.
quarter. Okay. Get this correct.
yes,
Get this correct.
I get this correct.
Nice. You get this correct. No, you lose a mark
No,
here.
I didn't have the trick. I found the correct range. I didn't get the less than. I put less than or equal to.
Oh, so you can lose a mark here too then. -1. Over here you get through with this.
Yes,
Right, and over here.
I
Yeah.
get this correct.
So you lose 30 marks. Damn. I didn't think it added up to so much.
Paper 1 for it, paper 1 out. Give my 1. After wrestle for that.
So like the worst case scenario, you get like 70 out of 100, which not bad enough. You're definitely in one territory. Yeah. Right. So that was it. That was it. What do you think about the solutions? You have anything to?
Nice. I learned thing. I learned about the exam after the exam. God.
I think it's a little too late, you know. I think it's a little too late. But
Too late.
oh, if you
I
do
will
it,
use it for pure maths in September.
for sure. And what you had to say to the ops?
Ups, I had no ups. Nobody know me.
No, for this, like my ops. You had to say to the ops.
Your ups. Well, man, keep this like it and think that.
You
You
know-
make all yourself look real sad when you see 10, 20 dislikes and the next thousands of likes. You'll be real lonely. Or if you could go by a campfire and
Exactly.
just watch it.
And what you had to say about the little mistakes we make along the way?
I should have revised more. The
No.
crash course really helped, man.
No.
I should have revised more.
No, that's it. And I'm glad it's helped. You're talking about like the little mistakes we make, like the simple mistakes we make throughout now. I mean, when you realize it was wrong, when we check back, does that teach our life lesson here?
Yes, check back your work.
Yeah.
If you help you like you're bossing.
Even if you're real good at maths like me, you're still prone to make mistakes. So that was it. You have a blessed night, and thank you for watching. To everybody who watching, bye everybody. Bye Achilles.
Good night, too.
Good night.
Yeah, bye.
Bye.